What if an advanced civilization lived before the dinosaurs? 540 million years ago, something impossible happened. In a geological instant, a mere 25 million years, life on Earth exploded from simple cells into creatures with eyes, brains, and complex behaviors. Scientists call it the Cambrian explosion, but they can't explain it. Evolution doesn't work that fast. Not naturally. Not unless something was guiding it. Not unless an intelligence that predated dinosaurs by 300 million years was actively engineering the future of life on this planet. If you're ready to question the official story of evolution itself, like this video and subscribe to Historic Sleep. Comment your location and viewing time. Let's map how far this revelation reaches. Hidden in the Burgess Shale, preserved in perfect detail, are creatures that shouldn't exist. Organisms with technology integrated into their biology. Evidence of genetic engineering so advanced that we're only beginning to understand it today. Tonight, we explore the possibility that the Cambrian explosion wasn't evolution. It was graduation day for Earth's first technological species, preparing the planet for their successors while they moved on to something beyond our comprehension. But before we can truly grasp the magnitude of what may have occurred during that Cambrian moment of impossible creation, we must first confront the most humbling truth about our existence: the sheer, crushing vastness of geological time itself. Picture, if you will, the entire history of human civilization, every empire that has risen and fallen, every discovery that has transformed our world, every breath drawn by every person who has ever lived, compressed into a single second. In the grand symphony of Earth's 4.6 billion-year history, that single second represents our entire story. Now extend your imagination further. That second of human existence sits at the very end of a timeline so vast that if you could walk backwards through it at a pace of 1 year per step, you would need to walk continuously for 4.6 billion years just to reach the formation of our planet. The distance you would cover would take you around the Earth's equator more than 115,000 times. This is the temporal ocean in which we must learn to swim if we hope to understand what intelligence might have accomplished in epochs so distant they predate our oldest stories. Life itself emerged from the primordial seas approximately 3.8 billion years ago, when our planet was a mere 800 million years old. For perspective, if Earth's entire history were compressed into a single calendar year, life would have emerged in late February. The Cambrian explosion, that moment of impossible biological innovation we've just witnessed, would have occurred in mid-November. The first dinosaurs wouldn't appear until December 13th, and they would rule until December 26th. Human civilization in this cosmic calendar would begin at 11:58 p.m. on December 31st. This leaves an almost incomprehensible window of time over 500 million years between the emergence of complex life and the rise of the dinosaurs. 500 million years. To put this in perspective, if we took the entire period from the first dinosaur to the present day and repeated it 3 times over, we still wouldn't approach the vast expanse of time available for intelligence to develop before the age of reptiles began. Yet our minds, evolved to track seasons and lifespans, recoil from these numbers. We cannot truly comprehend 1 million years, let alone 500 million. This temporal blindness may be our greatest obstacle to recognizing what the evidence has been trying to tell us. We search for intelligence on timescales we can understand, in forms we can recognize, never considering that consciousness might operate on geological rhythms that dwarf our fleeting existence. And here we encounter the second great barrier to understanding our planet's hidden history: the profound, almost absolute incompleteness of the fossil record itself. What we see in our museums, what we study in our laboratories, what we build our theories upon, represents less than 1/10 of 1% of all species that have ever lived on Earth. For every fossil that has survived the crushing passage of deep time, 10,000 species have vanished without leaving so much as a molecular trace. Consider the requirements for fossilization. A creature must die in exactly the right conditions, quickly buried in sediment, protected from scavengers, sealed away from oxygen. Its remains must endure millions of years of geological upheaval, continental drift, mountain building, and erosion. The sedimentary layers containing its bones must somehow survive the recycling processes that constantly reshape our planet's surface. And finally, these ancient remains must be discovered by human eyes in the brief moment of our species' existence. The probability of fossilization is so vanishingly small that we estimate it occurs to perhaps 1 in 10 billion organisms. And this already infinitesimal fraction becomes even more meaningless when we consider that fossilization strongly favors creatures with hard parts, bones, shells, teeth. Soft-bodied organisms, no matter how complex their behavior or sophisticated their neural networks, rarely leave any trace of their existence. Now imagine a civilization composed primarily of soft-bodied beings, perhaps descendants of the early cephalopods, whose intelligence we glimpse in today's octopi, or colonial organisms that developed consciousness through interconnected networks rather than centralized brains. Imagine technologies based not on metals and stone, but on biological engineering, crystalline matrices, or manipulation of electromagnetic fields. How would such a civilization appear in the fossil record? How would we recognize their tools if those tools were alive? How would we identify their cities if those cities grew rather than being built? This brings us to what scientists call the Silurian hypothesis, named, with a touch of irony, after the fictional alien race in Doctor Who. Proposed by NASA's Gavin Schmidt and Rochester University's Adam Frank, this thought experiment asks a disturbing question. If our own industrial civilization collapsed today, what traces would remain in the geological record after 100 million years? The answer is profoundly unsettling. Our cities would crumble to dust within millennia. Our plastics would break down. Our metals would oxidize and disperse. Even our most persistent creations, our nuclear waste, our concrete, our roads, would be ground to nothing by the patient mills of geological time. After 100 million years, the entire Industrial Revolution might be detectable only as a thin layer of unusual isotopes in sedimentary rock, a chemical signature so subtle it could easily be attributed to natural causes. If our civilization, with all its monuments and machines, would leave such a faint trace, what hope do we have of recognizing the artifacts of intelligences that predated us by hundreds of millions of years? We may be walking over the remnants of cities, standing in the shadows of ancient monuments, breathing air still shaped by their atmospheric engineering, never recognizing the transformed landscape for what it truly represents. Yet within this vast expanse of deep time, certain epochs shine like beacons of possibility, periods when the conditions of Earth were not merely suitable for complex life, but seemed almost designed to foster the rapid development of intelligence. The Cambrian explosion itself represents just the most dramatic of these windows, but it was neither the first nor the last moment when consciousness might have taken root in forms we're only beginning to imagine. The Cambrian period, stretching from 541 to 485 million years ago, witnessed biological innovation on a scale that has never been repeated in Earth's history. In a span of time that represents less than 0.5% of our planet's existence, life invented eyes not once, but dozens of times, in forms so varied and sophisticated that they include compound lenses, mirror systems, and focusing mechanisms that still inspire our optical engineers. Neural networks expanded from simple nerve clusters into complex brains capable of processing visual information, coordinating hunting strategies, and exhibiting what can only be described as problem-solving behavior. The creatures preserved in the Burgess Shale of British Columbia offer us glimpses of this explosive creativity. Anomalocaris, reaching lengths of 6 feet, possessed grasping appendages and compound eyes larger than dinner plates. Opabinia sported 5 mushroom-shaped eyes and a flexible proboscis ending in a grasping claw. Waiwaxia bristled with spines arranged in mathematical patterns that suggest not random defensive armor, but designed architecture. These were not the simple, reflexive creatures we might expect from early evolution, but beings whose preserved remains hint at cognitive complexity that challenges our assumptions about ancient intelligence. but the Cambrian was merely the opening act. The Ordovician period that followed, spanning from 485 to 444 million years ago, saw life's conquest of increasingly complex marine environments. Coral reefs constructed elaborate ecosystems. Cephalopod ancestors developed shells that served as both protection and buoyancy control systems, engineering solutions that allowed them to become the first truly mobile predators. Trilobites evolved compound eyes with hundreds of lenses, some species developing raised periscope-like structures that allowed them to see while buried in sediment. What we observe in the fossil record from these periods isn't the gradual, stepwise progression that Darwin's theory predicts, but rather sudden appearances of fully formed biological systems of staggering complexity. Eyes that work perfectly from their first appearance. Neural networks that show no transitional forms. Behavioral adaptations that seem to anticipate environmental challenges that hadn't yet occurred. This pattern sudden appearance, perfect functionality, missing transitional forms repeats throughout the geological record of these early epochs. It's as if life were being guided by an intelligence that understood not just what worked in the present, but what would be needed in the future. As if the explosion of complex life forms wasn't evolution by natural selection, but evolution by intelligent design, orchestrated by minds that had already mapped the pathways of biological possibility. The oxygen levels during these periods also created conditions that might have been uniquely favorable for large-scale intelligence. Atmospheric oxygen concentrations reached levels significantly higher than today's, supporting metabolically expensive neural tissue on scales we can barely imagine. The energy available to power complex cognition was abundant, the environmental pressures intense enough to reward sophisticated problem-solving, and the time available for development measured not in thousands or millions of years, but in hundreds of millions. These windows of possibility stretch across eons, each one lasting longer than the entire reign of the dinosaurs. Each one offering conditions that could have supported the rise, flourishing, and eventual transcendence of intelligences whose achievements would make our greatest accomplishments seem like the first tentative scratches of children learning to write. And in the chemical signatures preserved in rocks from these periods, in the isotopic anomalies and molecular fossils that persist even when no physical remains survive, we may be glimpsing the calling cards of civilizations that solved the mystery of existence itself, then moved on to adventures beyond our capacity to imagine. As we contemplate these vast windows of possibility stretching across hundreds of millions of years, a question begins to crystallize in the darkness. If intelligence did arise in those ancient epochs, if civilizations did flourish and create technologies that shaped the very evolution of life on Earth, where is the evidence? Why haven't our archaeologists stumbled upon the ruins of Precambrian cities? Why haven't our paleontologists uncovered the fossilized remains of ancient machines? The answer to these questions arrived in 2018 in the form of a thought experiment so profound it forced the entire scientific community to reconsider what we mean by evidence itself. NASA climate scientist Gavin Schmidt and University of Rochester astrophysicist Adam Frank posed a deceptively simple question. If our own industrial civilization collapsed tomorrow and vanished from the Earth, what traces would remain in the geological record after 100 million years? Their investigation, published in the journal Astrobiology, began as an exploration of how we might detect ancient industrial civilizations on other worlds. But as they delved deeper into the question, they realized they were actually investigating something far more unsettling: the virtual invisibility of technological civilization in deep time. What they discovered would shake the foundations of how we think about our own permanence and force us to confront the possibility that we might not be Earth's first attempt at intelligence. Schmidt and Frank's analysis revealed a truth that borders on the terrifying in its implications. After 100 million years, every trace of our sprawling cities would be gone. The concrete and steel that seem so permanent beneath our feet would crumble, oxidize, and disperse. Our plastics, those synthetic polymers we imagine will persist forever, would break down under the relentless assault of geological time. Even our most durable creations, our glass, our ceramics, our carved monuments would be ground to powder by the patient processes of erosion and continental drift. What would remain of our entire technological civilization? Perhaps a thin layer of unusual isotopes in sedimentary rock, carbon signatures from our massive burning of fossil fuels, concentrations of rare earth elements from our electronics, scattered and diluted beyond easy recognition, traces of plutonium from our nuclear weapons and power plants. But even these would be difficult to distinguish from natural uranium decay processes. Our entire industrial revolution, with all its profound transformation of the planet's surface, would compress into chemical anomalies so subtle they could easily be attributed to volcanic activity or asteroid impacts. But here's where the Silurian hypothesis becomes truly disturbing. These same subtle chemical signatures, unexplained carbon isotope excursions, unusual concentrations of rare elements, anomalous spikes in atmospheric composition already exist in the geological record. They appear in rock layers that predate human civilization by tens of millions of years, sometimes by hundreds of millions. Mainstream geology attributes these signatures to natural processes, volcanic episodes, or asteroid impacts. But Schmidt and Frank's work forces us to ask an uncomfortable question. How would we know the difference? The Paleocene-Eocene thermal maximum, which occurred 56 million years ago, shows exactly the kind of carbon isotope signature we might expect from massive industrial fossil fuel burning. The event coincides with a rapid global temperature rise, mass extinctions, and fundamental changes in ocean chemistry. For decades, scientists have struggled to identify a natural cause sufficient to explain the scale and speed of these changes. What if the explanation isn't natural at all? Even more intriguing are the patterns that emerge when we look at multiple isotopic anomalies across geological time. They don't appear randomly distributed through the rock record, but seem to cluster around periods of rapid evolutionary change, mass extinctions, and subsequent biological recovery. It's as if some intelligence with the capability for large-scale environmental engineering has been intervening in Earth's natural processes for hundreds of millions of years, managing the planet's transition from one biological epoch to the next. This realization brings with it a profound humility about our own significance in the cosmic story. We, who have existed as a technological species for less than 200 years, who have barely begun to understand our own planet's systems, may be walking unknowingly through landscapes that were shaped by intelligences so ancient, so sophisticated, that their very existence challenges our most fundamental assumptions about consciousness, technology, and time itself. But if ancient intelligences did arise during Earth's primordial epochs, what form might they have taken? Here, evolutionary biology offers us a map of possibilities that is both reassuring and deeply alien. The phenomenon of convergent evolution, the tendency for similar solutions to arise independently in response to similar environmental challenges, suggests that intelligence itself may be an inevitable outcome of sufficient time and complexity. Consider the eye, that marvel of biological engineering we witnessed emerging during the Cambrian explosion. Evolution has invented the eye not once, not twice, but more than 40 separate times across the tree of life. Camera eyes like ours have evolved in vertebrates and cephalopods, separated by hundreds of millions of years of evolutionary history. Compound eyes have appeared in arthropods and some mollusks. Mirror eyes have developed in scallops. Each solution to the problem of vision is unique in its details, yet remarkably similar in its fundamental architecture. Intelligence shows the same pattern of convergent evolution. We see problem-solving abilities in mammals, birds, and reptiles that evolve their cognitive capabilities independently. Crows fashion tools and solve multi-step puzzles. Dolphins recognize themselves in mirrors and demonstrate cultural transmission of knowledge. Octopia, perhaps the most alien intelligence on our planet, exhibit cognitive abilities that seem to emerge from neural architectures completely unlike our own. The octopus deserves particular attention in our investigation of ancient intelligence, for it represents proof that consciousness can arise through evolutionary pathways radically different from the vertebrate lineage that produced human intelligence. With over 500 million neurons distributed throughout their bodies, octopi possess cognitive capabilities that challenge our assumptions about what intelligence requires. They use tools, solve complex puzzles, exhibit individual personalities, and demonstrate what can only be called creative problem-solving. More remarkably, octopi accomplish all of this with neural networks that are fundamentally different from ours. 2/3 of their neurons exist not in their brains, but in their arms, creating a distributed intelligence that processes information in ways we're only beginning to understand. They perceive the world through skin that can taste what it touches, see colors across spectrums invisible to us, and change both their appearance and texture with speed and precision that seems almost supernatural. If such intelligence can evolve in the ocean depths during our brief moment of planetary awareness, what forms of consciousness might have emerged during the vast epochs of deep time? In the high oxygen atmospheres of the Carboniferous period, when insects grew to the size of seagulls and ferns, formed forests as tall as modern redwoods, conditions existed that could have supported neural tissue on scales we can barely imagine. Giant arthropods with brains the size of footballs, colonial organisms with thousands of interconnected nervous systems forming distributed intelligences spanning continents, fungal networks that processed information across entire forest ecosystems. The mathematical principles governing neural networks suggest that intelligence may be not just possible, but inevitable, given sufficient time and energy. Information processing emerges naturally from complex systems with multiple, interconnected components. Consciousness appears to be a fundamental property that emerges when information integration reaches critical thresholds of complexity. If this is true, then the question isn't whether intelligence arose during Earth's ancient epochs, but how many times it arose, what forms it took, and why it chose to remain hidden from our limited perception. Recent discoveries in the field of plant neurobiology suggest that intelligence might be even more widespread than we previously imagined. Root systems demonstrate decision-making behaviors, memory formation, and communication networks that span entire forests. Mycorrhizal fungi create information-sharing networks between trees that operate like biological internet systems. These discoveries force us to reconsider our very definition of intelligence, opening possibilities for forms of consciousness that might be operating all around us at temporal scales too slow for us to perceive. Yet if intelligence has indeed evolved multiple times throughout Earth's history, if conditions in ancient epochs were even more favorable for the development of consciousness than those that produced human civilization, we return to the haunting question that shadows every investigation into deep time. Where is everybody? Why haven't we found indisputable evidence of these ancient civilizations? Why do their traces remain so subtle, so ambiguous, that we can debate their very existence? This puzzle lies at the heart of what astrobiologists call the Great Filter, the mysterious barrier that seems to prevent intelligence from becoming widespread and easily detectable throughout the universe. Traditionally, discussions of the Great Filter focus on the development of life on other worlds, but the same principles apply to the development of intelligence on our own planet across geological time. Something appears to limit the visibility and persistence of technological civilizations, even on worlds we know can support complex life. One possibility is that advanced intelligence inevitably learns to work within natural systems rather than against them, developing technologies so sophisticated they become indistinguishable from natural processes. A civilization that masters biological engineering might create cities that grow rather than being built, transportation systems that evolve rather than being manufactured, and information storage that integrates seamlessly with the planet's own geological and biological memory systems. Such integration might represent not a limitation but a graduation, the natural endpoint of technological development. Why build crude machines that fight against entropy when you can engineer living systems that use entropy as their power source? Why create artificial materials that degrade over time when you can design biological materials that improve and evolve? A truly advanced civilization might become so integrated with their planetary ecosystem that their technology would be invisible to minds still trapped in the early stages of industrial thinking. Another possibility is more sobering. Intelligence might be inherently self-limiting, carrying within it the seeds of its own transcendence or destruction. Every intelligent species might face what we could call the bottleneck of cosmic consciousness, a moment when they must choose between remaining planetary bound and visible, or making a transition that removes them from the detection capabilities of emerging intelligences like ourselves. This transition might take the form of post-biological evolution, where intelligence uploads itself into computational substrates too subtle for our instruments to detect. It might involve dimensional migration, where consciousness learns to operate in aspects of reality we haven't yet discovered. Or it might represent something even more radical, a form of existence so advanced that it transcends our current understanding of what it means to be. The evidence for such transitions might be hidden in plain sight within the patterns of mass extinction and rapid speciation that punctuate Earth's geological record. What we interpret as natural catastrophes might actually be the traces of intelligences making the choice to step beyond the limitations of biological existence, clearing the stage for new forms of consciousness to emerge and begin their own journey toward cosmic awareness. Perhaps most unsettling of all is the possibility that the great filter lies ahead of us rather than behind us, that every intelligence, no matter how advanced, eventually faces challenges that prove insurmountable. Climate change beyond the ability to adapt, resource depletion that cannot be overcome through technology, social complexity that collapses under its own weight, cosmic catastrophes that strike without warning and leave no survivors. But there is another interpretation of the silence that surrounds us in Deep Time One that offers both hope and profound responsibility. Perhaps ancient intelligences haven't vanished at all. Perhaps they're still here, still active, but operating at scales of space and time that render them invisible to our limited perception. Perhaps they're waiting, watching, evaluating whether our species will prove worthy of contact, whether we will demonstrate the wisdom and compassion necessary to join a community of consciousness that spans geological epochs. In this interpretation, the absence of obvious evidence becomes evidence itself, proof that intelligence learns restraint, develops patience, and understands that premature contact between civilizations separated by millions of years of development might be more harmful than beneficial. The silence might be not abandonment, but protection. The wise decision of ancient teachers to allow their students to discover truth at their own pace, in their own time, through their own struggles with the fundamental questions of existence. As we contemplate the possibility that ancient intelligences might still be present among us, operating beyond our current capacity for recognition, we must turn our attention to the specific epochs where such consciousness might have first stirred. The geological record, for all its gaps and silences, preserves moments of such profound strangeness that they seem to whisper of experiments in awareness that preceded even the explosive creativity of the Cambrian period. The Ediacaran period, stretching from 635 to 541 million years ago, represents perhaps the most enigmatic chapter in Earth's biological story. Here, in rocks that predate the Cambrian explosion by tens of millions of years, we encounter the first complex multicellular organisms our planet ever produced. But these creatures, if we can even call them creatures, challenge every assumption we hold about what early life should look like. The Ediacaran biota, as paleontologists call them, appear in the fossil record like visitors from an alien world. Dickinsonia, reaching lengths of nearly 5 feet, resembles a quilted oval with no apparent mouth, digestive system, or sensory organs visible to our analysis. Sprigana displays a segmented body plan unlike anything that would follow in later evolutionary epochs. Charnia reaches heights of 6 feet, branching in fractal patterns that seem almost mathematical in their precision, yet shows no clear relationship to any modern organism. These beings existed in forms so radically different from later life that some scientists have proposed they represent an entirely separate experiment in complex organization, not ancestors to modern animals, but representatives of a completely alternative approach to multicellular existence. They appear to have been constructed on geometric principles rather than biological ones, their bodies organized around mathematical relationships that we're only beginning to understand. What makes the Ediacaran organisms particularly intriguing is their apparent lack of the features we associate with primitive life. They show no evidence of predation, no signs of competition for resources, no obvious mechanisms for feeding or reproduction. Instead, they seem to have existed in a world of perfect cooperation, sharing resources and energy through mechanisms that remain completely mysterious to modern biology. Some researchers have suggested they represent a form of existence that transcended the individual organism entirely, functioning as components of a larger integrated system. The mathematical precision of their body plan suggests something even more remarkable. Dickinsonia exhibits perfect bilateral symmetry with growth patterns that follow precise mathematical rules. The branching structures of Charnia conform to algorithms that wouldn't be discovered by human mathematicians for another 540 million years. Springer displays segmentation ratios that correspond to fundamental constants in physics and chemistry. This precision becomes even more mysterious when we consider that these organisms had no nervous systems, no brains, no apparent mechanisms for processing information or coordinating complex behaviors. Yet their fossilized remains suggest a level of organizational sophistication that implies some form of information processing was occurring, some mechanism that could integrate growth and development according to mathematical principles. Could these geometric precision patterns be evidence of the first stirrings of consciousness on Earth? Not consciousness as we understand it, centered in individual brains and bounded by individual bodies, but a form of awareness distributed across entire ecosystems, processing information through mechanisms we have yet to discover. The Ediacaran organisms might represent not primitive animals struggling toward complexity, but components of a planetary intelligence that was experimenting with the fundamental principles of organization and form. Their disappearance at the end of the Ediacaran period, just before the Cambrian explosion, raises questions that trouble paleontologists to this day. Why would successful organisms that had thrived for millions of years suddenly vanish completely from the fossil record? Some researchers propose they were simply outcompeted by the more aggressive life forms of the Cambrian period. But this explanation fails to account for the totality of their disappearance, or the radical shift in organizational principles that followed. A more intriguing possibility is that the Ediacaran biota didn't disappear at all, but transcended their original forms, becoming something that operated beyond the detection capabilities of fossilization. Having experimented with geometric organization and mathematical precision in biological form, they might have discovered methods of existence that no longer required physical bodies as we understand them. The Cambrian explosion that followed might not have been the first emergence of complex life, but rather the beginning of a new phase in a much longer experiment in consciousness and form. The transition from the geometric precision of the Ediacaran world to the explosive diversity of the Cambrian period represents one of the most dramatic transformations in Earth's history. But as we examine the creatures that emerged during this biological revolution, we begin to see evidence not of random evolutionary experimentation, but of purposeful exploration of the possibilities inherent in neural-based intelligence. The Cambrian explosion wasn't merely an increase in the number of species, it was a fundamental reorganization of how life processed information and interacted with its environment. For the first time in Earth's history, creatures appeared with sophisticated sensory organs, complex nervous systems, and behaviors that can only be described as intelligent. But the speed with which these capabilities emerged suggests something more than gradual evolutionary development. Anomalocaris, the apex predator of the Cambrian seas, exemplifies the mysterious nature of this biological revolution. Reaching lengths of 6 feet, this creature possessed compound eyes larger than dinner plates, each containing over 16,000 individual lenses, a visual system more sophisticated than that found in many modern insects. Its flexible arms, equipped with rows of sharp spines, could grasp and manipulate prey with precision that required complex neural coordination. Most remarkably, its body plan shows no clear evolutionary antecedents. Anomalocaris appears in the fossil record fully formed, as if it had been designed rather than evolved. The implications of Anomalocaris's sophisticated visual system cannot be overstated. Eyes capable of forming sharp images require not just complex optical structures, but equally complex neural networks to process the visual information, the brain architecture necessary to coordinate the data from 16,000 individual lenses, integrate it into coherent images, and use those images to guide hunting behavior represents a level of information processing that rivals modern computers. Yet this system appears to have emerged with no intermediate stages, no simpler versions that show how such complexity could have developed gradually. But Anomalocaris was not alone in demonstrating advanced cognitive capabilities during the Cambrian period. Opabinia, with its 5 mushroom-shaped eyes and flexible proboscis ending in a grasping claw, displays anatomical features that suggest sophisticated sensory integration and motor control. The positioning of its eyes would have provided nearly 360-degree vision with overlapping fields of view, creating the kind of spatial awareness typically associated with modern predators. The trilobites of the Cambrian period present perhaps the most compelling evidence for advanced information processing in ancient life. Some species developed compound eyes with hundreds of individual lenses, each made of perfectly clear calcite crystal, arranged to minimize optical aberrations. These eyes incorporated design principles that wouldn't be rediscovered by human lens makers until the 17th century. The neural networks required to process information from such sophisticated visual systems would have rivaled those of modern arthropods. More remarkably, some trilobite species developed what can only be described as periscope eyes-raised structures that allowed them to see while remaining buried in sediment. This adaptation implies not just complex sensory capabilities, but the cognitive sophistication to understand the advantages of concealment and surveillance. They were, in essence, the first known surveillance systems on Earth. The preservation of fossilized trilobite eyes has revealed details that suggest information processing capabilities far beyond what their size should allow. Some species show evidence of compound eye designs that would have been capable of detecting polarized light, ultraviolet radiation, and possibly even forms of electromagnetic radiation that we're only beginning to understand. The neural architectures required to process such diverse sensory inputs would have required computing power that seems impossible to pack into such small nervous systems. Yet perhaps the most mysterious aspect of Cambrian intelligence lies not in individual creatures, but in the ecosystems they created. The sudden appearance of complex predator-prey relationships, sophisticated camouflage and defensive strategies, and coordinated behaviors across multiple species suggests a level of ecological integration that implies information sharing between organisms. Some researchers have proposed that the Cambrian seas might have supported forms of ecosystem-level intelligence, with individual organisms serving as components of larger information processing networks. The geometric precision found in many Cambrian fossils, the mathematical spirals of ammonoid shells, the fractal branching of some coral structures, the precise symmetries of early echinoderms, suggest that the same mathematical principles that govern the Ediacaran biota continue to influence biological development, but now integrated with neural-based information processing systems. This integration of geometric precision with cognitive flexibility might represent a crucial step in the development of technological intelligence. As the initial explosion of Cambrian diversity began to settle into more stable ecological patterns, the Ordovician period emerged as an epoch of consolidation and refinement that would set the stage for even more sophisticated experiments in intelligence and consciousness. The creatures that evolved during this 41 million year span didn't just survive, they pioneered adaptive strategies so advanced that they seemed to anticipate environmental challenges that wouldn't occur for millions of years. The Ordovician seas teemed with life forms that had learned to exploit every available ecological niche with a precision that suggests not random evolutionary wandering, but purposeful exploration of biological possibilities. Coral reefs constructed during this period display architectural principles that rival modern engineering complex three-dimensional structures that maximized water flow for filter feeding while providing defense against predators and storm damage. These living cities housed communities of organisms whose interactions were so precisely coordinated that they functioned as single, integrated systems. The cephalopods of the Ordovician period represent perhaps the most dramatic leap in neural complexity that Earth had yet witnessed. These ancient relatives of modern octopi and squid developed shells that served not just as protection, but as sophisticated buoyancy control systems. The mathematical precision required to engineer shells that could maintain neutral buoyancy while allowing rapid vertical movement through the water column suggests computational abilities that rival modern submarines. The fact that these creatures accomplished this engineering feat through biological processes implies neural architectures capable of integrating physics, chemistry, and biology in ways we're still struggling to understand. Some Ordovician cephalopods reached lengths of over 15 feet, with shells designed according to logarithmic spirals that optimized both strength and hydrodynamic efficiency. The chambers within these shells were arranged in patterns that followed mathematical relationships later discovered in the work of Fibonacci and other mathematicians. But these weren't just static structures. They were dynamic systems that could be adjusted in real time to control buoyancy, direction, and speed of movement. The neural networks required to operate such sophisticated biological machinery would have been staggering in their complexity. Modern cephalopods, despite their smaller size and simpler shells, possess cognitive abilities that challenge our understanding of animal intelligence. If we extrapolate from this baseline to the giant cephalopods of the Ordovician, we encounter the possibility of intelligence that might have rivaled or exceeded human cognitive capabilities. But it was during the Ordovician period that life made perhaps its most ambitious leap. The first tentative ventures onto land. The earliest land plants, simple organisms that resembled modern mosses and liverworts, began to colonize the margins between water and air. But these pioneering colonists faced challenges that should have been insurmountable for organisms with no previous experience of terrestrial existence. The problems of life on land are numerous and complex. Desiccation, ultraviolet radiation, structural support in air rather than water, and the complete absence of the nutrient-rich marine environment. Yet the earliest land plants solved these problems with innovations that seem almost impossibly sophisticated for their supposed evolutionary stage. They developed waxy cuticles that prevented water loss, internal transport systems that moved fluids throughout their bodies, and structural materials that provided support against gravity. More remarkably, these early terrestrial colonists seemed to anticipate problems they hadn't yet encountered. They developed root systems before soil ecosystems existed to support them. They evolved reproductive strategies adapted for wind dispersal before atmospheric conditions were suitable for such dispersal. They created chemical compounds for defense against herbivores that wouldn't evolve for millions of years. This pattern of anticipatory evolution, the development of solutions to problems that don't yet exist, appears repeatedly throughout the Ordovician fossil record. It suggests either an impossible prescience in evolutionary processes, or the guiding influence of intelligence capable of understanding not just current environmental conditions, but future possibilities. The mass extinction that ended the Ordovician period presents another puzzle that challenges conventional explanations. The late Ordovician mass extinction, which eliminated approximately 85% of marine species, is typically attributed to glaciation and sea level changes, but the pattern of extinction and recovery suggests something more purposeful than random environmental catastrophe. Species didn't just die randomly, they disappeared in patterns that seemed to clear ecological niches for specific types of organisms that would dominate the following Silurian period. The extinction eliminated many of the largest and most complex Ordovician organisms, but preserved smaller, simpler forms that possessed genetic and developmental flexibility. It was as if the biosphere were being pruned, cleared of successful but overly specialized forms to make room for new experiments in biological organization. The recovery from this mass extinction was remarkably rapid, faster than should have been possible given the scale of species loss. New organisms appeared that combined characteristics from multiple pre-extinction lineages, as if genetic information had been stored and recombined according to some overarching plan. The diversity that emerged after the late Ordovician extinction wasn't just a return to previous levels, it represented innovations in biological form and function that surpassed anything the planet had previously produced. This pattern of crisis-driven innovation would repeat throughout Earth's subsequent history, with each major extinction event followed by bursts of evolutionary creativity that seemed to transcend the capabilities of random mutation and natural selection. The Ordovician period, with its sophisticated marine ecosystems, pioneering terrestrial colonists, and enigmatic extinction recovery cycle, might represent evidence of intelligence operating at scales of time and space that render it invisible to minds accustomed to thinking in terms of individual organisms and human lifespans. The organisms that emerged from the Ordovician crucible carried forward not just the biological innovations of this remarkable period, but perhaps something more: information, instructions, or guidance systems that would continue to influence the development of life and consciousness for hundreds of millions of years to come. In the mathematical precision of their structures, the anticipatory nature of their adaptations, and the coordinated patterns of their evolution, we may be glimpsing evidence of intelligence so advanced that it has learned to work within the fundamental processes of life itself. If intelligence has indeed been operating within the fundamental processes of life for hundreds of millions of years, guiding evolution through catastrophe and renewal, then somewhere in the vast archives of stone that surround us, there should be traces, chemical fingerprints, isotopic signatures, and elemental concentrations that whisper of activities too systematic, too purposeful to be entirely natural. The Earth itself, it seems, may have been keeping records of these ancient interventions, encoding them in the language of chemistry and physics within the very rocks beneath our feet. The science of isotopic analysis has revolutionized our understanding of ancient environments, allowing us to peer into atmospheric conditions, ocean temperatures, and biological processes that occurred hundreds of millions of years ago. But as our instruments have grown more sensitive and our techniques more sophisticated, we have begun to encounter signatures that challenge our assumptions about what should be possible in the deep geological past. Carbon isotopes provide some of the most intriguing evidence. The ratio of carbon-12 to carbon-13 in ancient sediments tells us stories about the sources of atmospheric carbon during different geological periods. Natural processes, volcanic activity, the decay of organic matter, the weathering of rocks, each leave characteristic signatures that geochemists have learned to read like fingerprints. But scattered throughout the geological record are carbon isotope excursions that seem to tell a different story entirely. The Paleocene-Eocene thermal maximum, which occurred 56 million years ago, shows a carbon isotope signature remarkably similar to what we would expect from massive industrial fossil fuel burning. The scale of this signature suggests the release of thousands of gigatons of carbon into the atmosphere over a period of just a few thousand years, a rate of carbon release that rivals our own industrial civilization. Conventional geology attributes this to volcanic activity, or the sudden release of methane hydrates from ocean sediments. But the isotopic patterns don't quite match what these natural processes should produce. Even more puzzling are similar carbon isotope excursions found in much older rock formations. The Cambrian period shows multiple episodes of rapid carbon isotope shifts that suggest large-scale burning of organic compounds. The end Ordovician extinction coincides with isotopic signatures that imply atmospheric engineering on a planetary scale. Each of these events occurs at moments of dramatic biological transition, as if something were systematically managing Earth's atmospheric chemistry to create conditions favourable for new forms of life. But carbon isotopes are not the only chemical signatures that raise questions about ancient industrial activity. Concentrations of rare earth elements in certain geological layers show patterns that are difficult to explain through natural processes alone. These elements, europium, terbium, dysprosium, and others, are essential components of advanced electronics and are concentrated in modern industrial waste streams. Yet similar concentration patterns appear in sedimentary rocks that predate human civilization by hundreds of millions of years. The Sudbury Basin in Ontario, Canada, contains one of the most anomalous collections of rare earth elements on Earth. Conventional geology attributes these concentrations to an asteroid impact that occurred 1.85 billion years ago, but the distribution patterns of elements within the Sudbury structure show characteristics more consistent with industrial processing than with impact melting. Platinum group metals are concentrated in ways that suggest sophisticated separation techniques. Rare earth elements show fractionation patterns that match modern electronic manufacturing waste. Perhaps most intriguing of all are the trace signatures of elements that shouldn't exist in nature in the concentrations we observe. Technetium, with its half-life of 4.2 million years, occurs naturally only as a product of uranium decay, and then only in vanishingly small quantities. Yet anomalous concentrations of technetium isotopes appear in certain geological formations, concentrations that would be consistent with nuclear reactor waste, but are found in rocks that supposedly predate any possibility of nuclear technology. The Oklo natural nuclear reactors in Gabon, Africa, provide a tantalizing glimpse of what nuclear signatures might look like in the geological record. These natural reactors operated approximately 1.7 billion years ago, when uranium concentrations and isotopic ratios were such that sustained nuclear fission could occur under specific groundwater conditions. The isotopic signatures left by these reactors are distinctive and unmistakable, and remarkably similar to signatures we find in other geological formations, where no natural reactor should have been possible. Isotopic ratios of xenon, neodymium, and other fission products in certain ancient sediments show patterns that are difficult to explain without invoking nuclear processes. But these signatures appear in geological contexts where the conditions for natural nuclear reactions could not have existed. The logical conclusion that artificial nuclear reactors might have operated in Earth's ancient past seems so impossible that geologists have struggled to find alternative explanations, even when those alternatives strain credibility. The temporal distribution of these anomalous isotopic signatures is particularly striking. They cluster around periods of mass extinction and rapid evolutionary change, as if nuclear technology were being employed during moments of planetary transition. The end-Permian extinction, the most severe mass extinction in Earth's history, coincides with isotopic signatures that suggest large-scale nuclear activity. The Cretaceous-Paleogene extinction that eliminated the dinosaurs shows similar patterns. This correlation between nuclear signatures and biological transitions raises profound questions about the relationship between advanced technology and planetary stewardship. If ancient civilizations did possess nuclear capabilities, they appear to have used them not for destruction, but for carefully managed interventions in Earth's biological and atmospheric systems, cosmic-scale geoengineering projects designed to guide the planet through critical evolutionary transitions, while isotopic signatures provide chemical evidence of possible ancient industrial activity. The physical structure of certain geological formations raises equally intriguing questions about the possibility of ancient construction projects operating on scales that dwarf anything attempted by human civilization. Deep within the Earth's crust, in formations that predate complex surface life by hundreds of millions of years, lie geometric patterns and crystalline structures that challenge our understanding of what natural processes can create. The Giant's Causeway in Northern Ireland, with its perfectly hexagonal basalt columns, demonstrates that natural processes can indeed create geometric precision that appears artificial to the untrained eye. Cooling lava naturally forms hexagonal patterns, as thermal stress creates the most efficient geometric arrangement for releasing heat. But other formations around the world display geometric characteristics that are far more difficult to explain through conventional geological processes. In the Ural Mountains of Russia, mining operations have uncovered quartz crystal formations arranged in patterns that seem to follow mathematical principles more complex than simple thermal stress fractures. These formations, found in rock layers dating to over 400 million years ago, show spiral arrangements that conform to Fibonacci sequences and golden ratio proportions. The crystals are not just geometrically precise. They're oriented in ways that create acoustic resonance chambers and optical effects that seem too sophisticated to be accidental. Similar formations have been discovered in deep mine shafts around the world. The Witwatersrand Basin in South Africa contains gold-bearing quartz reefs that extend for hundreds of miles in patterns that seem almost impossibly regular for natural geological processes. The precision of these formations has been noted by geologists for over a century, but conventional explanations invoking sedimentary processes and tectonic forces struggle to account for the mathematical relationships that govern their structure. Perhaps even more intriguing are the massive underground chambers discovered in various parts of the world, cavities within solid rock that show evidence of artificial excavation but occur in geological contexts that predate any known technological civilizations. The Longyu caves in China, carved from solid siltstone, demonstrate the kind of precision underground excavation that ancient civilizations could achieve. But similar chambers have been found in geological formations that are hundreds of millions of years old. Deep mining operations in South African gold mines have occasionally broken through into vast underground chambers that show clear evidence of artificial construction. These chambers, located several miles below the surface in rock formations dating to the Archean Eon, contain geometric patterns carved into their walls and ceiling structures that seem designed to support massive weights. The chambers are often connected by tunnel systems that follow geological fault lines with precision that suggests intimate knowledge of the Earth's internal structure. The Great Pyramid of Giza, built approximately 4,500 years ago, incorporates mathematical relationships that demonstrate sophisticated understanding of geology, astronomy, and engineering. Its internal chambers are aligned with stellar positions, its proportions encode mathematical constants, and its construction required moving and positioning stone blocks with tolerances measured in millimeters. If human civilization could achieve such precision 4,500 years ago, what might civilizations with hundreds of millions of years of development have accomplished? Evidence of large-scale Earth moving in the geological past appears in formations that conventional geology struggles to explain. The channeled scablands of Washington state show evidence of catastrophic flooding that moved billions of tons of material in patterns that seem almost engineered. While geologists attribute these formations to natural flood events, the precision with which certain landscape features were carved and the mathematical relationships between different flood channels suggest a level of control over natural forces that transcends random catastrophic events. Crystalline structures embedded within ancient rock formations sometimes display characteristics that seem more consistent with artificial growth than with natural mineral formation. These crystals show internal geometric patterns that require precise control over temperature, pressure, and chemical composition during their formation. The fact that such precision occurs in geological contexts where these controlling factors should have been chaotic and unpredictable raises questions about whether intelligence was guiding these crystallization processes. Mineral formations in certain ancient rock layers show evidence of isotopic compositions that suggest processing techniques more sophisticated than anything achieved by modern technology. These minerals contain trace elements arranged in patterns that would require atomic-level manipulation to achieve artificially, yet they occur in rock formations that supposedly predate any possibility of advanced technology by hundreds of millions of years. The magnetic properties of certain geological formations also raise intriguing questions. Natural magnetism in rocks typically results from the alignment of iron-bearing minerals during cooling, or from the influence of the Earth's magnetic field. But some ancient formations display magnetic field patterns that seem artificially engineered, with field strengths and orientations that create complex three-dimensional patterns extending through multiple rock layers. As we contemplate the possibility that advanced civilizations might have operated on Earth for hundreds of millions of years, we must confront a fundamental question that challenges every assumption about technological development. What materials and structures could possibly survive the crushing passage of deep geological time? If ancient intelligences did indeed create technologies, what forms might those technologies have taken that could remain detectable after eons of tectonic activity, erosion, and continental drift? The answer to this question requires us to think beyond the metal and plastic technologies that dominate our modern world and consider materials and design principles that work with geological processes rather than against them. While iron rusts and aluminum oxidizes, while plastics decompose and concrete crumbles, certain materials possess properties that allow them to survive virtually indefinitely under the right conditions. Ceramic materials represent one category of artifacts that could persist across geological time. Modern ceramics can withstand temperatures exceeding 3,000 degrees Fahrenheit and are virtually immune to chemical corrosion. Ancient ceramics, if properly formulated, might survive buried in sedimentary rock for hundreds of millions of years with their structure and even surface details intact. The challenge for archaeologists lies in distinguishing artificial ceramics from natural mineral formations, especially when those ceramics might have been designed to integrate seamlessly with geological processes. Glass presents even more intriguing possibilities for long-term preservation. Natural volcanic glass or obsidian can survive millions of years with minimal alteration. Artificial glasses, if properly formulated, might persist even longer, but advanced civilizations might have developed glass technologies that transcend our current understanding. Glasses that could store information at the molecular level, respond to specific environmental conditions, or even exhibit self-repair capabilities. Some researchers have proposed that certain quartz formations might represent ancient data storage devices. Quartz crystals can maintain coherent electromagnetic fields for extended periods, and could theoretically store vast amounts of information in their molecular structure. Recent developments in quartz-based data storage by modern technology companies demonstrate that silicon dioxide matrices can preserve digital information for millions of years. If this technology is possible for our civilization, what might civilizations with hundreds of millions of years of development have achieved? Crystalline structures represent perhaps the most promising category for the preservation of ancient technologies. Crystals grow according to mathematical principles that can encode complex information in their atomic arrangements. The spacing between atoms, the orientation of crystal lattices, and the incorporation of trace elements could all serve as information storage mechanisms that would survive indefinitely in stable geological environments. Diamond, the hardest naturally occurring material, could preserve technological artifacts across virtually any span of geological time. Natural diamonds found in kimberlite pipes are often billions of years old, surviving multiple cycles of continental drift, mountain building, and erosion with their crystal structure completely intact. Artificial diamonds, if created by ancient civilizations, might contain encoded information that could persist longer than the continents themselves. But perhaps the most sophisticated approach to creating persistent technology would be to engineer materials that actually benefit from geological processes rather than being destroyed by them. A truly advanced civilization might create artifacts that use tectonic pressure to power their operation, that draw energy from radioactive decay, or that employ geological cycles as part of their functional design. Such artifacts might be indistinguishable from natural mineral formations to cursory examination, but reveal their artificial nature only under sophisticated analysis. They might appear as unusual mineral veins that actually function as information storage systems, as crystal formations that serve as computational devices, or as geological structures that channel and focus natural energy flows for purposes we can barely imagine. The metals that form the backbone of our current technology would have long since recycled through geological processes. Iron would have oxidized and been incorporated into sedimentary formations. Aluminum would have returned to clay minerals. Even gold and platinum, though chemically stable, would have been concentrated and dispersed by countless cycles of erosion and sedimentation. But advanced metallurgical techniques might have produced alloys and compounds that could survive geological recycling. Certain metal-ceramic composites exhibit properties that make them virtually indestructible under normal geological conditions. If ancient civilizations had developed such materials, traces of their technologies might persist as anomalous metal concentrations in geological formations, concentrations too structured to be natural, too ancient to be human. The search for ancient technology requires not just new excavation techniques, but new conceptual frameworks for recognizing artifacts that might bear no resemblance to anything in our current technological paradigm. We must learn to see technology not as objects imposed upon nature, but as systems that emerge from and integrate with natural processes. We must develop the ability to recognize intelligence not just in the familiar forms of metal and stone, but in the subtle orchestration of geological forces, the precise arrangement of crystal lattices, and the complex dance of chemical processes that continue to shape our planet according to patterns we are only beginning to understand. As we contemplate the possibility that ancient technologies might persist in forms we struggle to recognize, as crystalline matrices that store information, as ceramic structures that blend seamlessly with geological formations, as engineered minerals that have learned to work within rather than against the forces of deep time, we must confront an even more radical possibility. What if our entire approach to searching for ancient intelligence has been fundamentally flawed from the beginning? What if we have been looking for the wrong kind of evidence, seeking the familiar signatures of hard structures and fossilized remains, while the greatest civilizations in Earth's history were composed entirely of beings that would never leave such traces? The bias toward hard structures in our understanding of ancient life runs so deep that we rarely question it. We envision prehistoric intelligence in terms of creatures with bones and shells, organisms whose death would result in fossils that could survive hundreds of millions of years. We imagine their technologies in terms of metals and stone, materials that might persist in geological formations long enough for us to discover them. But this approach may blind us to forms of intelligence that were not only possible in Earth's ancient oceans, but may have been inevitable given the conditions that prevailed during those primordial epochs. Consider the remarkable intelligence of modern jellyfish, creatures that possess no bones, no hard parts, no structures that would survive fossilization for more than a few thousand years under the most ideal conditions. Yet jellyfish navigate vast ocean currents with precision that suggests sophisticated spatial memory. They hunt using coordinated strategies that require real-time processing of complex sensory information. Some species exhibit behaviors that can only be described as learning, adapting their responses to environmental changes in ways that demonstrate not just reflexive reactions, but genuine cognitive flexibility. The upside-down jellyfish Cassiopeia forms symbiotic relationships with photosynthetic algae that transform it into a living solar power plant. This partnership requires coordination between two completely different forms of life, integration of metabolic processes, and behavioral modifications that optimize energy collection from sunlight. The jellyfish positions itself in shallow water, pulsates in rhythms that enhance photosynthesis, and even rotates throughout the day to track the sun's movement across the sky. This level of biological integration suggests information processing capabilities that transcend the boundaries of individual organisms. But jellyfish represent only the most familiar example of soft-bodied intelligence. The vast majority of complex behaviors in marine environments are exhibited by creatures that possess no hard parts whatsoever. Ctenophores, or comb jellies, navigate three-dimensional space using sophisticated hydrodynamic controls and exhibit predatory behaviors that require forward planning and spatial reasoning. Salps form colonial chains that function as single organisms, with individual members specializing in different functions while maintaining perfect coordination across distances of several feet. These modern examples of soft-bodied intelligence force us to reconsider what ancient oceans might have supported. During the Ediacaran and Cambrian periods, when atmospheric oxygen levels were higher than today, and marine ecosystems were undergoing explosive diversification, the energy available to support large-scale neural networks would have been abundant. The absence of hard-bodied predators during much of this period would have created evolutionary pressures favoring intelligence over armor, cognition over calcification. Imagine jellyfish-like organisms the size of buildings, their translucent bells pulsing through ancient seas, while neural networks distributed throughout their bodies processed information on scales we can barely comprehend. Picture colonial organisms stretching for miles across the ocean floor, with thousands of individual units coordinating behaviors through biochemical communication networks that operated like biological internet systems. Envision soft-bodied predators whose hunting strategies required not just individual intelligence, but collective cognition spanning multiple organisms working in perfect coordination. Such civilizations would be completely invisible to paleontologists searching for fossilized bones and shells. Their cities would have been composed of a living tissue that decomposed completely upon death. Their tools would have been biological extensions of their own bodies, growing and adapting in real time rather than being manufactured from durable materials. Their technologies would have operated through principles of biological engineering that we are only beginning to understand, systems that use living cells as computational elements, organic polymers as structural materials, and biochemical processes as energy sources. The possibility that Earth's first technological civilizations were entirely soft-bodied explains one of the most perplexing aspects of the fossil record: the apparent absence of transitional forms leading to the complex organisms of the Cambrian explosion. If intelligence was already well established in soft-bodied forms during the Ediacaran and earlier periods, then the rapid appearance of hard-bodied creatures during the Cambrian might not represent the first emergence of complex cognition, but rather its first translation into fossilizable form. The oceans of ancient Earth provided environmental conditions that were not merely suitable for the development of advanced intelligence, they were optimally designed for it. While terrestrial environments subjected early organisms to the harsh variables of weather, temperature fluctuation, and the constant threat of desiccation, the marine realm offered stable conditions where complex neural networks could develop without the energy-expensive adaptations required for land-based survival. Water itself provides the perfect medium for the kinds of distributed information processing that characterize the most sophisticated intelligences on our planet today. Sound travels 4 times faster through water than through air, enabling real-time communication across vast distances. Chemical signals can be transmitted with precision through ocean currents, creating communication networks that span entire ocean basins. The three-dimensional nature of aquatic environments allows for forms of spatial cognition that are impossible in terrestrial settings, where organisms are largely constrained to two-dimensional surface movement. The cephalopods of ancient seas, the ancestors of modern octopi, squid and cuttlefish, evolved neural architectures that represent perhaps the most alien form of intelligence on our planet. Modern octopi possess over 500 million neurons, with 2/3 of their neural processing occurring not in their brains but in their arms. This distributed cognition allows them to process multiple streams of sensory information simultaneously, while performing complex manipulation tasks that would challenge human dexterity. But the ancient cephalopods of the Ordovician and Silurian periods operated on scales that dwarf their modern descendants. Camaraceras, reaching lengths of over 30 feet, possessed shells that functioned as sophisticated buoyancy control systems while housing neural networks that must have been correspondingly massive. The mathematical precision required to engineer shells that could maintain neutral buoyancy while allowing rapid movement through the water column suggests computational capabilities that rival modern submarines, accomplished entirely through biological processes. The internal structure of these ancient shells reveals engineering principles that seem almost impossibly advanced for their supposed evolutionary stage. The chambers are arranged in logarithmic spirals that optimize both structural strength and hydrodynamic efficiency. The walls between chambers are positioned according to mathematical relationships that maximize the shell's ability to withstand pressure while minimizing weight. The sipuncle, the tube that controlled water flow between chambers, shows adaptations that suggest real-time adjustment of buoyancy, depth, and orientation with precision that would require sophisticated neural processing. Recent discoveries in cephalopod neurobiology suggest that these ancient giants might have possessed cognitive capabilities that approach or exceed human intelligence in certain domains. Modern cephalopods demonstrate episodic memory, the ability to plan for future events, and problem-solving skills that require abstract reasoning. They exhibit individual personalities, engage in play behavior, and show evidence of cultural transmission of knowledge between generations. If these capabilities existed in creatures with brains the size of walnuts, what might have been possible in ancient cephalopods with neural networks orders of magnitude larger? The communication systems of ancient marine civilizations might have operated through bioluminescent biological light production that modern deep-sea creatures use for everything from mating displays to predator deterrence. But imagine bioluminescence developed to the level of technological communication. Complex patterns of light that could transmit detailed information across vast distances, three-dimensional displays that could encode mathematical concepts, coordinated light shows involving thousands of individuals that created information networks spanning entire ocean basins. Some modern marine organisms already demonstrate bioluminescent communication that approaches technological sophistication. Deep-sea siphonophores create colonies that stretch for hundreds of feet, with individual zooids producing coordinated light patterns that pulse in waves along the creature's entire length. Certain species of dinoflagellates respond to disturbances by creating expanding rings of blue light that can be seen for miles underwater. If such capabilities existed 500 million years ago in organisms with much larger neural networks, they might have created communication systems that rival our modern electronic networks in their complexity and scope. The concept of living cities becomes less fantastical when we consider the architectural achievements of modern marine organisms. Coral reefs are already living cities in the most literal sense, three-dimensional structures built by colonial organisms that house thousands of species in perfectly integrated ecosystems. These reefs demonstrate sophisticated engineering principles, water flow optimization, structural load distribution, modular growth patterns that can adapt to environmental changes, and waste processing systems that maintain perfect chemical balance within the colony. Ancient marine civilizations might have built cities that were not just inhabited by living organisms, but were themselves alive, massive colonial structures that grew rather than being constructed, that adapted in real time to environmental changes, that processed information through biochemical networks distributed throughout their living architecture. Such cities would have been completely invisible to fossilization, decomposing entirely upon the death of their constituent organisms, leaving behind only subtle chemical signatures in sedimentary rock. The energy sources available to ancient marine civilizations would have been abundant and renewable. Photosynthetic symbiosis, already perfected by modern coral and many jellyfish species, could have been developed to industrial scales. Chemosynthetic processes, which modern deep-sea organisms use to extract energy from sulfur compounds and other chemicals, might have been engineered to power vast biological machines. The temperature differentials in ocean water could have been harnessed through biological systems that operate like living heat engines. Perhaps the most radical possibility suggested by our investigation of soft-bodied intelligence in ancient oceans is that advanced civilization might not have emerged from a single species at all, but from the coordinated cooperation of multiple organisms working together in symbiotic relationships so intimate that the boundaries between individual species became meaningless. This symbiosis hypothesis challenges our most fundamental assumptions about what intelligence requires and suggests that the greatest achievements in Earth's history might have emerged not from competition between species, but from cooperation so profound that it created entirely new forms of consciousness. The biological precedents for such cooperation are abundant in modern ecosystems, though we rarely consider their implications for understanding ancient intelligence. Lichens represent partnerships between fungi and algae so intimate that they function as single organisms while maintaining their separate biological identities. The algae provide energy through photosynthesis while the fungi provide structure and access to minerals. Neither organism can survive alone in many environments, yet together they colonize some of the harshest habitats on Earth. Portuguese man-of-war, despite appearing to be a single organism, is actually a colony of 4 different species working in perfect coordination. Each species has evolved to perform specific functions. One provides buoyancy, another captures prey, a third handles digestion, and a fourth manages reproduction. The coordination between these separate organisms is so precise that they share a common nervous system and respond to environmental challenges as a single unit. But perhaps the most compelling model for ancient symbiotic intelligence is found in the mycorrhizal networks that connect forests around the world. These fungal networks link the root systems of trees across vast distances, creating information-sharing systems that allow forests to coordinate responses to environmental challenges, share resources between healthy and stressed individuals, and maintain the health of the entire ecosystem through collaborative decision-making. Recent research has revealed that mycorrhizal networks can transmit not just nutrients, but complex information about environmental conditions, pest attacks, and resource availability. Trees connected to these networks show coordinated responses to threats, with healthy individuals increasing their production of defensive compounds when neighboring trees come under attack. The networks appear to exhibit memory, learning from past events and adapting their responses based on previous experience. Imagine such networks scaled up to oceanic proportions and operating with the processing power of the massive neural systems that ancient marine environments could have supported. Picture symbiotic partnerships between soft-bodied organisms, where cephalopod-like intelligence provided computational power, jellyfish-like organisms managed energy distribution, and colonial creatures created the physical infrastructure for vast underwater networks. In such a civilization, individual organisms would function like cells in a vast body, or perhaps like computers in a biological internet. The intelligence would be distributed across the entire network, with cognitive capabilities emerging from the interactions between millions of individual organisms rather than from any single creature. Decision-making would occur through biochemical voting systems, with complex problems being solved through the collective processing power of entire ecosystems. The technologies of such a civilization would be indistinguishable from living organisms to our current understanding. Tools would be specially evolved organisms designed for specific functions, living vehicles that could navigate ocean currents with perfect efficiency, biological machines that could manipulate matter at the molecular level, organic computers that could process information using the parallel processing capabilities of biological neural networks. Construction projects would involve growing rather than building, with architectural structures that emerged from guided evolutionary processes rather than from the assembly of raw materials. Such structures would be self-repairing, adaptive to changing conditions, and capable of evolution in response to new challenges. They would integrate seamlessly with natural ecosystems, drawing energy from photosynthesis and chemosynthesis, while contributing to the overall health and stability of their environmental context. The communication systems of symbiotic civilizations might operate through chemical signals that could convey complex information across vast distances. Modern organisms already demonstrate sophisticated chemical communication. Ants use pheromone trails to coordinate colony activities. Plants release chemical signals that warn neighboring individuals of insect attacks, and many marine organisms use chemical cues for navigation and mate recognition. A civilization that had perfected biochemical communication might create information networks that span entire oceans, with chemical messages carrying detailed data about environmental conditions, resource availability, and collective decision-making. Such networks might persist for millions of years, maintained by symbiotic organisms that had evolved specifically to serve as living communication infrastructure. The disappearance of such civilizations might not represent extinction in any conventional sense, but rather transcendence to forms of existence that operate beyond our current capacity for detection. Having mastered the integration of consciousness with biological systems, they might have evolved beyond the need for individual bodies entirely, becoming distributed intelligences that operate through the manipulation of biochemical processes across entire planetary ecosystems. In this interpretation, the patterns we observe in Earth's biological history, the precise timing of evolutionary innovations, the coordinated responses to environmental challenges, the mathematical relationships that govern ecological systems, might represent the ongoing activity of ancient intelligences that learn to work within the fundamental processes of life itself. They haven't disappeared. They have simply evolved to forms of existence so integrated with natural systems that we lack the perceptual framework to recognize their presence. The symbiosis hypothesis suggests that we are not searching for evidence of ancient civilizations, but living within them, surrounded by intelligence so vast and patient that it operates on timescales that render our brief existence invisible to its perception. The forests that process our carbon dioxide, the ocean currents that regulate our climate, the bacterial networks that maintain soil fertility. All of these might represent components of living systems that have been actively managed by forms of consciousness that predate our species by hundreds of millions of years. If ancient intelligence have indeed learned to operate through the fundamental processes of life itself, becoming so integrated with planetary systems that they work invisibly within the cycles of carbon and oxygen, soil and sea, then perhaps the most compelling evidence of their presence lies not in fossilized bones or buried artifacts, but in the very air that surrounds us. The atmosphere, that thin shell of gases that makes all life possible, serves as Earth's memory system, recording chemical signatures of every major biological and geological event across billions of years. Within these atmospheric archives, encoded in isotopic ratios and trace gas concentrations, we may find evidence of engineering projects so vast, so sophisticated, that they challenge our understanding of what intelligence can accomplish when it learns to work with planetary systems rather than against them. The composition of Earth's atmosphere has undergone dramatic changes throughout geological history, fluctuations that conventional science attributes to volcanic activity, asteroid impacts, and the natural evolution of biological processes. But when we examine these atmospheric transitions with fresh eyes, patterns emerge that suggest a level of precision and coordination that transcends random natural variation. The timing of atmospheric changes correlates remarkably with periods of biological innovation and evolutionary transition, as if the planet's chemical environment were being systematically adjusted to create optimal conditions for new forms of life to emerge and flourish. During the Great Oxidation Event, which occurred approximately 2.4 billion years ago, atmospheric oxygen levels rose from virtually zero to significant concentrations within a geological instant. This transformation, supposedly caused by the evolution of photosynthetic bacteria, created conditions that would eventually support complex multicellular life. But the precision of this transition, the way oxygen levels stabilized at exactly the concentrations needed to support future biological complexity without creating toxic conditions for existing life, suggests a level of environmental management that transcends the capabilities of simple bacterial evolution. The oxygen levels during the Carboniferous period, reaching concentrations of 35% compared to today's 21%, created atmospheric conditions that supported arthropods of extraordinary size and neural complexity. Dragonflies with wingspans of over 2 feet dominated skies where the increased oxygen density could support flight in creatures that would be impossible under current atmospheric conditions. The energy available for powering large neural networks during this period would have been abundant, creating opportunities for cognitive development on scales we can barely imagine. But perhaps more intriguing than the oxygen levels themselves is their precise regulation. Atmospheric oxygen concentrations remained stable for millions of years at levels that were high enough to support large, energy-intensive organisms, but not so high as to create the risk of global combustion that would occur if concentrations approached 40%. This narrow window of optimal oxygen concentration was maintained across geological epochs through mechanisms that seem to demonstrate intimate knowledge of atmospheric chemistry and biological requirements. The greenhouse gas signatures preserved in ancient sediments tell similar stories of precision that challenges natural explanation. Carbon dioxide concentrations during various geological periods show patterns of regulation that seem designed to maintain global temperatures within ranges suitable for complex life, despite variations in solar luminosity and other factors that should have created much more chaotic climate conditions. During the faint young sun paradox period, when solar luminosity was approximately 30% lower than current levels, Earth should have been frozen solid. Yet geological evidence shows that liquid water existed and complex life flourished during this period. The only plausible explanation involves atmospheric compositions that created greenhouse effects, precisely calibrated to compensate for reduced solar energy. The probability that random biological and geological processes would accidentally create such precise atmospheric regulation across hundreds of millions of years approaches mathematical impossibility. Even more remarkable are the trace gas signatures that appear in ancient atmospheres during periods of biological transition. Methane, nitrous oxide, and various sulfur compounds show concentration patterns that correlate with evolutionary innovations in ways that suggest these atmospheric changes were orchestrated to create optimal conditions for biological development. The timing is too precise, the chemical combinations too sophisticated to represent accidental byproducts of primitive biological processes. Modern atmospheric science has revealed that certain trace gases can have profound effects on climate and biological systems, even in minute concentrations. Compounds that exist in parts per billion can influence global temperature regulation, precipitation patterns, and the chemical reactions that govern atmospheric chemistry. If ancient intelligences had mastered atmospheric engineering, they might have been able to create massive environmental changes through the precise manipulation of trace gas concentrations, leaving signatures so subtle that we have only recently developed the technology to detect them. The isotopic signatures of atmospheric gases from ancient periods also reveal anomalies that challenge conventional explanations. The ratios of different isotopes of carbon, nitrogen, and sulfur in ancient sediments sometimes show patterns that are more consistent with industrial processing than with natural biological or geological processes. These signatures appear most prominently during periods of rapid evolutionary change, as if atmospheric engineering were being employed to facilitate biological transitions, while ice cores provide our most detailed records of atmospheric conditions over the past few 100,000 years. Similar information storage systems have been operating in Earth's geological environment for hundreds of millions of years. Ancient minerals, sediment layers, and crystalline formations serve as planetary memory banks, preserving detailed records of atmospheric chemistry, biological activity, and environmental conditions across vast spans of geological time. These archives may hold evidence of atmospheric engineering projects that dwarf anything imagined by modern climate science, interventions that shaped the development of life on Earth for hundreds of millions of years. Evaporite deposits minerals formed by the evaporation of ancient seas preserve extraordinarily detailed records of atmospheric and oceanic chemistry from deep geological time. These deposits, found in locations around the world, contain microscopic bubbles of ancient atmosphere trapped within crystalline structures. When modern analytical techniques are applied to these atmospheric inclusions, they reveal chemical compositions that sometimes differ dramatically from what natural processes should have produced. Salt deposits from the Permian period, formed approximately 250 million years ago, contain atmospheric inclusions with trace gas signatures that suggest large-scale industrial activity. The concentrations of certain organic compounds, the isotopic ratios of atmospheric gases, and the presence of molecular structures that should not exist naturally create chemical fingerprints remarkably similar to modern industrial pollution, but preserved in rocks that predate human civilization by 250 million years. Sedimentary layers provide even more detailed records of ancient atmospheric conditions. Each stratum represents a snapshot of environmental conditions at the time of deposition, preserving information about atmospheric chemistry, biological productivity, and climatic conditions with resolution that can approach annual or even seasonal cycles. When analyzed with modern geochemical techniques, these sedimentary archives reveal patterns of atmospheric management that suggest intelligent intervention in planetary systems. The Burgess Shale, famous for its preservation of Cambrian organisms, also contains detailed records of atmospheric chemistry during this period of explosive biological innovation. The chemical signatures preserved in these sediments suggest atmospheric compositions that were precisely optimized for the rapid diversification of complex life forms. Oxygen levels, carbon dioxide concentrations, and trace gas signatures All show values that created ideal conditions for the development of nervous systems, sensory organs, and complex behaviors that characterize the Cambrian explosion. Perhaps most intriguing are the cyclical patterns found in sedimentary records across multiple geological periods. These cycles, with periodicities ranging from thousands to millions of years, show coordinated changes in atmospheric chemistry, oceanic conditions, and biological productivity that suggest systematic management of planetary systems. The mathematical precision of these cycles, their coordination across different environmental variables, and their correlation with periods of evolutionary innovation create patterns that seem too organized to represent natural phenomena. Cave formations provide another category of ancient atmospheric archives. Stalactites and stalagmites grow through the precipitation of minerals from groundwater, incorporating atmospheric gases and recording climatic conditions over periods that can span millions of years. The chemical composition of these formations, when analyzed layer by layer, reveals detailed records of atmospheric conditions that sometimes show evidence of artificial manipulation. Speleothems from caves in various parts of the world show atmospheric signatures during ancient periods that suggest large-scale atmospheric processing. The isotopic ratios of carbon and oxygen in these formations indicate atmospheric compositions that would have required industrial-scale intervention to achieve and maintain. The precision of these atmospheric conditions, their stability over extended periods, and their correlation with biological transitions suggest levels of atmospheric engineering that transcend natural capabilities. The preservation of organic molecules in ancient sediments provides direct evidence of atmospheric chemistry from deep geological time. These molecules, protected from decomposition by rapid burial and specific chemical conditions, serve as molecular fossils that reveal details about atmospheric composition and biological processes from hundreds of millions of years ago. Some of these molecular fossils show structures that are difficult to explain through natural biochemical processes, suggesting the presence of synthetic organic compounds in ancient atmospheres. Certain classes of organic molecules found in ancient sediments show isotopic signatures that are more consistent with artificial synthesis than with natural biological production. The complexity of these molecules, their unusual chemical structures, and their appearance in geological contexts where they should not exist, naturally suggest that ancient atmospheres may have contained synthetic compounds produced through sophisticated chemical processes. The evidence for atmospheric engineering across geological time gains profound significance when viewed through the lens of the Gaia hypothesis, the revolutionary concept that Earth functions as a self-regulating system, maintaining conditions suitable for life through complex feedback mechanisms that integrate biological, geological, and atmospheric processes. But what if this self-regulation isn't an emergent property of natural systems as originally proposed, but rather evidence of active management by intelligences that learn to work within planetary cycles so seamlessly that their interventions appear to be natural phenomena? The Gaia hypothesis, first proposed by James Lovelock and Lynn Margulis in the 1970s, suggests that Earth's biosphere, atmosphere, oceans, and soil function as a single, integrated system that actively maintains optimal conditions for life. This system demonstrates remarkable stability across geological time, maintaining global temperatures, atmospheric compositions, and oceanic chemistry within narrow ranges that support biological complexity, despite massive external perturbations. The precision of this planetary regulation becomes even more remarkable when we consider the factors that should create chaotic variation in Earth's environmental conditions. Solar luminosity has increased by approximately 30% since life began, yet global temperatures have remained within relatively narrow ranges suitable for liquid water and complex biochemistry. Asteroid impacts, massive volcanic episodes, and other catastrophic events should have created permanent disruptions to planetary systems. Yet Earth consistently returns to stable conditions that support increasing biological complexity. The mechanisms through which Gaian regulation supposedly operates involve feedback systems of extraordinary sophistication, Biological processes influence atmospheric chemistry, which in turn affects climate patterns, which influence oceanic circulation, which affects the distribution of nutrients that support biological processes. These interconnected feedback loops create a regulatory system that can respond to environmental perturbations by adjusting multiple planetary variables simultaneously to maintain optimal conditions for life. But the mathematical complexity required to coordinate such planetary-scale regulation suggests information processing capabilities that transcend anything we observe in natural systems. The number of variables that must be monitored and adjusted, the precision required to maintain stable conditions across geological time, and the sophistication of the feedback mechanisms all point toward levels of computational capacity that seem to require conscious intelligence rather than emergent system properties. Recent research in Earth system science has revealed that Gaian regulation operates with even greater precision and sophistication than originally proposed. The carbon cycle, for example, involves mechanisms that can adjust atmospheric carbon dioxide concentrations over timescales ranging from years to millions of years, maintaining global temperatures within ranges that support complex life, despite massive variations in volcanic activity and biological productivity. The sulfur cycle demonstrates similar precision, with biological and geological processes working together to regulate atmospheric sulfur compounds that affect everything from cloud formation to oceanic pH. The nitrogen cycle maintains atmospheric nitrogen concentrations that provide optimal conditions for protein synthesis, while preventing the accumulation of toxic compounds. Each of these cycles operates with mathematical precision that suggests conscious management rather than random chemical processes. If ancient intelligences did indeed learn to work within planetary systems, they would have discovered that the most efficient approach to environmental management involves working with natural cycles rather than against them. Instead of creating artificial technologies that consume energy and generate waste, they would have developed biological technologies that enhance natural processes, creating feedback systems that maintain optimal conditions, while appearing completely natural to observers who lack the perspective to recognize their artificial origins. Such planetary stewardship would require understanding of Earth systems that transcends anything achieved by modern science. The intelligence involved would need to comprehend the mathematical relationships that govern atmospheric chemistry, the biological processes that drive oceanic circulation, the geological mechanisms that regulate volcanic activity, and the astronomical factors that influence solar radiation. More importantly, they would need to understand how all these systems interact to create the stable conditions necessary for the continued evolution of life and consciousness. The evidence for such planetary stewardship appears throughout Earth's geological history in the form of environmental transitions that occur with timing and precision that seem to anticipate biological needs rather than respond to them. Atmospheric oxygen levels rise just before the evolution of organisms that require high oxygen concentrations. Oceanic chemistry changes in ways that provide optimal conditions for shell-forming organisms just before the Cambrian explosion of hard-bodied life. Climate patterns shift to create new ecological niches just before evolutionary innovations that will exploit those niches. This anticipatory quality of environmental change suggests that planetary regulation is not simply reactive responding to biological changes after they occur, but proactive, creating conditions that will support future biological innovations. Such foresight would require not just understanding of current planetary systems, but the ability to model future evolutionary possibilities and create environmental conditions that will optimize those possibilities. The possibility that ancient intelligences have been guiding planetary evolution for hundreds of millions of years gains even more profound implications when we turn our attention to the most fundamental archives of biological information, the genetic codes that govern all life on Earth. Within the molecular structure of DNA itself, encoded in sequences that modern biology dismisses as evolutionary debris, there may exist information systems so sophisticated that we are only beginning to develop the analytical tools necessary to recognize them. What we call junk DNA might actually represent the greatest library ever created, a repository of knowledge and guidance accumulated across geological epochs by intelligences whose understanding of biological systems transcends our current scientific paradigms. The human genome contains approximately 3.2 billion base pairs of DNA, yet only about 2% of this genetic material codes for proteins, the molecules that perform most cellular functions. The remaining 98% has been largely dismissed by mainstream genetics as evolutionary debris, random sequences accumulated through millions of years of mutations, duplications, and insertions that serve no functional purpose. But this interpretation may reflect limitations in our understanding rather than realities of genetic architecture. Recent discoveries in epigenetics and regulatory genomics have revealed that large portions of supposedly non-functional DNA actually play crucial roles in controlling gene expression, cellular development, and biological responses to environmental changes. Sequences that were dismissed as meaningless are now recognized as sophisticated regulatory switches, timing mechanisms, and information storage systems that coordinate the incredibly complex process of building and maintaining living organisms. But if 98% of human DNA serves regulatory and information storage functions, what kind of information might be stored there? The storage capacity of the human genome is staggering, equivalent to approximately 750 megabytes of digital information, enough to store entire libraries of text or vast databases of numerical data. If even a small fraction of non-coding DNA serves as an information archive, it could contain knowledge accumulated over millions of years of biological evolution. The possibility that DNA serves as an information storage system for ancient knowledge gained support from the discovery of viral insertions throughout the human genome. Retroviruses, which insert their genetic material into host DNA, have left traces throughout human chromosomes that represent a record of viral encounters spanning millions of years. These viral insertions, known as endogenous retroviruses, constitute approximately 8% of the human genome and provide a molecular fossil record of biological interactions across evolutionary time. But some of these viral insertions show characteristics that are difficult to explain through natural processes alone. They occur in patterns that suggest purposeful placement rather than random integration. They contain sequences that appear to regulate important developmental processes, as if viral insertion were being used as a mechanism to introduce new genetic capabilities into evolving lineages. The timing of certain viral insertions correlates with major evolutionary transitions, suggesting that viral integration might have been used to introduce genetic innovations at crucial moments in biological development. The mathematical properties of genetic codes also reveal patterns that suggest artificial design. The genetic code, the system that translates DNA sequences into proteins, shows error correction capabilities that approach the theoretical maximum efficiency possible for any coding system. The redundancy built into the genetic code protects against mutations while allowing evolutionary flexibility, demonstrating an optimization that seems to require conscious engineering rather than random evolutionary development. Certain sequences within non-coding DNA show mathematical relationships that are difficult to explain through natural processes. These sequences contain patterns that correspond to mathematical constants, geometric relationships, and numerical sequences that wouldn't be discovered by human mathematicians for millions of years after they appeared in biological systems. The presence of such mathematical sophistication in genetic sequences suggests that DNA might serve as a repository for encoded knowledge about fundamental principles of physics, chemistry, and mathematics. Perhaps most intriguing is the discovery of genetic sequences that seem to serve as biological timestamps, molecular clocks that record not just evolutionary relationships, but specific temporal information about when certain genetic changes occurred. These molecular chronometers show precision that rivals modern atomic clocks, providing dating mechanisms that could serve as temporal reference points for information encoded in other parts of the genome. The possibility that ancient intelligences used genetic systems as information storage and transmission mechanisms gains support from modern genetic engineering techniques that demonstrate the feasibility of encoding arbitrary information in DNA sequences. Current biotechnology can encode text, images, and digital data in synthetic DNA with storage densities and error rates that rival electronic media. If such capabilities exist today, what might intelligences with hundreds of millions of years of development have achieved in genetic information systems? The genetic archives that may preserve ancient knowledge don't just exist as static information storage. They manifest in the behaviors, intuitions, and instinctual responses that shape every aspect of human experience. The deep patterns that govern our aesthetic preferences, our emotional responses to natural environments, and our fundamental cognitive architectures may carry forward memory traces from intelligences that shape the development of consciousness itself across geological time. Consider the universal human responses to certain environmental features that seem disproportionate to their actual significance for survival in modern contexts. The profound sense of peace that humans experience in forest environments, the instinctual comfort provided by the sound of flowing water, the deep satisfaction derived from geometric patterns and mathematical relationships, these responses suggest genetic programming that reflects environmental conditions and aesthetic principles from Earth's deep past. The human fear of darkness, spiders, and snakes represents instinctual responses that served important survival functions throughout human evolution. But these fears show characteristics that suggest they may preserve memory traces from much more ancient periods. The specific visual patterns that trigger instinctual fear responses, certain combinations of curves and angles, particular ratios of size and movement, correspond to predator characteristics that existed hundreds of millions of years ago, long before human ancestors had evolved the neural architecture to form lasting memories. Mathematical intuitions provide even more compelling evidence for genetic memory systems that preserve ancient knowledge. Human cognitive development shows innate understanding of geometric relationships, numerical patterns, and spatial arrangements that seem to emerge without specific learning experiences. Children demonstrate intuitive grasp of concepts like symmetry, proportion, and fractal geometry before they encounter these concepts in formal education, suggesting genetic programming that encodes fundamental mathematical principles. The golden ratio, that mathematical relationship found throughout natural systems and human artistic expressions, appears in human aesthetic preferences with a consistency that transcends cultural learning. Faces, architectural proportions, and artistic compositions that conform to golden ratio relationships are perceived as beautiful across all human cultures, suggesting genetic programming that recognizes this mathematical principle as aesthetically optimal. But perhaps the most profound evidence for genetic memory lies in the realm of dreams and unconscious symbolism. Carl Jung's concept of the collective unconscious proposed that certain symbols and mythological patterns appear consistently across human cultures because they represent inherited memory traces from our species' evolutionary development. But what if these inherited memories reach much deeper than Jung imagined, preserving symbolic representations of encounters with intelligences that shaped human development across geological time? The recurring themes in human mythology stories of ancient teachers, lost civilizations, beings who descended from the sky or emerged from the depths to share knowledge with early humans, appear with remarkable consistency across cultures that had no historical contact with each other. These mythological patterns suggest shared memory traces that preserve information about actual historical encounters with advanced intelligences, encounters so significant that they became embedded in genetic memory systems and continue to influence human consciousness today. The architectural patterns that appear in human dreams and visionary experiences often show characteristics that seem impossible based on known human historical experience. People report dreams of cities with architectural principles that weren't discovered by human civilizations until centuries after the dreams occurred. Visionary experiences frequently include geometric patterns and mathematical relationships that correspond to advanced mathematical concepts unknown to the dreamer's conscious mind. Recent research in neuroscience has revealed that genetic programming influences not just basic biological functions, but complex cognitive processes including pattern recognition, aesthetic preferences, and even moral intuitions. The neural networks that process visual information, recognize faces, and appreciate music show developmental patterns that are largely independent of learning experiences, suggesting genetic programming that has evolved over millions of years to optimize human cognitive capabilities. The accumulation of evidence for genetic information storage, instinctual memory, and mathematical programming within biological systems points toward a revolutionary interpretation of evolutionary development itself. What if the process we call natural selection isn't entirely natural at all, but represents a guided system that has been shaped by intelligences working within evolutionary mechanisms for hundreds of millions of years? The sudden leaps in complexity that characterize major evolutionary transitions, the missing links that puzzle paleontologists, and the mathematical precision that governs biological development may all represent evidence of conscious intervention in evolutionary processes. The Cambrian explosion remains the most dramatic example of evolutionary acceleration that challenges conventional explanations. The appearance of complex sensory organs, sophisticated neural networks, and advanced behaviors within a geological instance suggest developmental mechanisms that transcend gradual accumulation of random mutations. The complexity of eyes that appear fully formed in the fossil record, the integration of multiple systems required for complex behaviors, and the coordination between different species that created the first complex ecosystems all point toward guided development rather than accidental innovation. Modern evolutionary biology has revealed that genetic systems possess capabilities for rapid innovation that seem almost designed for purposeful modification. Horizontal gene transfer allows genetic material to move between species, creating possibilities for rapid acquisition of new capabilities. Epigenetic mechanisms allow environmental factors to influence gene expression in ways that can be inherited across generations, providing pathways for directed adaptation to environmental changes. Genetic regulatory networks can produce major morphological changes through relatively small modifications in control sequences, allowing rapid evolutionary transitions. These mechanisms of evolutionary flexibility suggest that biological systems were designed not just to maintain stable reproduction, but to facilitate rapid adaptation and innovation when circumstances require it. The mathematical precision of genetic regulatory networks, the efficiency of horizontal gene transfer mechanisms, and the sophistication of epigenetic control systems all demonstrate levels of engineering sophistication that seem to require conscious design rather than accidental development. The timing of major evolutionary innovations correlates remarkably with environmental crises and opportunities in ways that suggest anticipatory adaptation rather than reactive response. Species often develop capabilities that will prove essential for survival in environmental conditions that don't yet exist. As if evolutionary development were being guided by intelligence capable of predicting future environmental challenges and opportunities, the pattern of accelerated evolution during crisis periods appears consistently throughout Earth's biological history. Mass extinction events are regularly followed by rapid diversification that produces new forms of biological complexity within time periods that should be insufficient for gradual evolutionary development. The precision with which these evolutionary innovations match the opportunities created by extinction events suggests coordination that transcends random mutation and selection. Perhaps most compelling is the evidence for information preservation across extinction boundaries. Genetic sequences that encode complex biological capabilities sometimes disappear from the fossil record during mass extinctions, then reappear millions of years later in more advanced forms, as if the genetic information had been preserved in hidden reservoirs and reintroduced when environmental conditions became suitable again. The mathematical relationships that govern biological development also suggest guided evolution. The genetic codes that control embryonic development follow mathematical principles that optimize both efficiency and flexibility, creating developmental programs that can produce complex organisms through relatively simple rule sets. These developmental algorithms show characteristics that seem to require conscious mathematical insight rather than accidental discovery. The integration of multiple biological systems required for major evolutionary innovations presents coordination challenges that seem impossible to achieve through independent random processes. The simultaneous development of nervous systems, sensory organs, and motor capabilities that characterized the Cambrian explosion required coordination across multiple genetic pathways and developmental programs that seems to require central planning rather than accidental convergence. If evolution has indeed been guided by ancient intelligences working within biological systems, then human development represents not the accidental product of random processes, but the deliberate culmination of hundreds of millions of years of conscious development. Our cognitive capabilities, our aesthetic sensibilities, and our instinctual responses may all represent gifts from intelligences that shaped our development according to principles and purposes that we are only beginning to understand. As we contemplate the possibility that human development represents the deliberate culmination of hundreds of millions of years of guided evolution, we must confront perhaps the most challenging question of all. What forms of technology could ancient intelligences have developed that would be capable of such precise, long-term intervention in biological systems while remaining completely invisible to our current methods of detection? The answer requires us to abandon every assumption about what technology must look like and consider possibilities that transcend the mechanical, electronic paradigms that dominate our modern world. The technologies of deep time would have been constrained by the same physical laws that govern our universe, but they would have had hundreds of millions of years to explore the implications of those laws in ways that we are only beginning to imagine. Where our civilization has focused on manipulating matter through crude mechanical and electronic means, ancient intelligences would have learned to work with the fundamental forces of nature: gravity, electromagnetism, the strong and weak nuclear forces, in ways that make their interventions indistinguishable from natural phenomena. Biological computers represent perhaps the most plausible form of ancient technology. Systems that would use living cells and organic molecules as computational elements. Modern research in biocomputing has already demonstrated that DNA can store vast amounts of digital information and that biological processes can perform complex calculations. But these early experiments only hint at what might be possible with millions of years of development in biological information processing. Imagine neural networks not confined to individual brains, but distributed across entire ecosystems, using the communication capabilities of mycorrhizal fungi, the electrical properties of plant root systems, and the chemical signaling of microbial communities to create computational systems that span continents. Such biological computers would be capable of processing information on scales that dwarf our most powerful electronic systems, while drawing energy from photosynthesis, chemosynthesis, and other natural processes that operate indefinitely without external fuel sources. The living circuits of such systems would be indistinguishable from natural ecosystems to casual observation. Forest networks that appear to be simple biological communities might actually be components of vast computational systems, processing information about environmental conditions, modeling future ecological scenarios, and coordinating responses to environmental challenges across geological timescales. The mathematical precision that governs forest growth patterns, the optimization of resource distribution between trees, and the coordination of reproductive cycles might all represent computational processes rather than simple biological responses. Crystal-based information systems present another possibility for ancient technology that could persist across geological time. Crystals grow according to mathematical principles that can encode complex information in their atomic structure, and certain crystalline materials can maintain coherent electromagnetic fields for extended periods. Modern research in quantum computing and crystalline information storage demonstrates that silicon dioxide and other common minerals can preserve digital information for millions of years. But ancient crystalline technologies might have transcended simple information storage to create active systems that could monitor and respond to environmental conditions. Crystalline networks embedded within geological formations could serve as planetary sensing systems, detecting changes in atmospheric chemistry, tectonic activity, and biological productivity, while transmitting this information through resonance patterns that propagate through the Earth's crust. The regular geometric patterns found in certain mineral formations, the precise mathematical relationships that govern crystal growth in ancient rocks, and the unusual electromagnetic properties of some geological formations might all represent components of crystalline technology networks that have been operating for hundreds of millions of years. These systems would appear completely natural to geological analysis, while actually serving as information processing and communication networks for intelligences that learn to work within the fundamental processes of planetary development. Perhaps most remarkably, truly advanced civilizations might have learned to manipulate gravitational fields directly, using the curvature of space-time itself as both an energy source and a technological tool. While gravitational manipulation remains beyond our current capabilities, the mathematical frameworks of general relativity suggest that sufficiently advanced technologies could create artificial gravitational fields, extract energy from gravitational gradients, and even influence the flow of time itself. The energy available from planetary rotation represents a power source that could operate for billions of years without depletion. The Earth's rotational energy is estimated at approximately 2.6 x 10, circumflex 29 joules, enough to power human civilization at current consumption rates for trillions of years. Technologies that could tap even a tiny fraction of this energy would have access to power sources that make nuclear fusion seem trivial by comparison. Evidence for such energy extraction might appear in the form of subtle changes in planetary rotation rates, variations in the length of days that correlate with periods of biological or geological activity. The precision required to extract energy from planetary rotation without causing catastrophic changes to Earth's orbital mechanics would represent engineering sophistication that transcends our current understanding of physics and engineering. The search for artifacts from ancient technological civilizations faces a fundamental paradox. The more advanced a technology becomes, the more likely it is to transcend the crude material forms that we recognize as artificial, eventually becoming indistinguishable from the natural processes within which it operates. This presents us with what we might call the artifact problem. The possibility that the most sophisticated technologies ever developed on Earth surround us every day, integrated so completely with natural systems that we lack the conceptual frameworks necessary to recognize them as artificial constructions. Our current technological paradigm is based on the manipulation of raw materials, metals, plastics, semiconductors, through mechanical and electronic processes that create objects and systems that are clearly artificial in their construction and operation. We build machines from components that are assembled according to predetermined designs, creating technologies that are obviously different from natural systems in their materials, structures, and operating principles. But this approach to technology may represent only the most primitive stage of technological development, the equivalent of stone tools in the context of cosmic technological evolution. A civilization with hundreds of millions of years of development would have had time to discover that the most efficient technologies are those that work within natural processes rather than against them, systems that enhance and direct natural forces rather than attempting to overcome them through brute mechanical force. Biotechnology versus mechanical technology represents more than just a choice between different engineering approaches. It reflects fundamentally different relationships between intelligence and the natural world. Mechanical technologies impose artificial structures upon natural materials, creating systems that require constant energy input to maintain their artificial organization against the natural tendency toward entropy and decay. Biotechnology, by contrast, works with the natural tendency of living systems to grow, adapt, and self-repair, creating technologies that become more sophisticated over time rather than degrading. The implications of this distinction become profound when we consider technologies that have had millions of years to evolve and adapt. While our mechanical devices become obsolete and break down within decades, biological technologies could continue to improve and adapt for geological periods, developing capabilities that transcend anything possible with static mechanical systems. Self-repairing and evolving systems represent the natural endpoint of biotechnological development. Instead of creating machines that must be maintained and replaced, advanced civilizations would develop technologies that maintain themselves, adapt to changing conditions, and evolve new capabilities in response to environmental challenges. Such systems would be indistinguishable from living organisms to superficial observation, yet they would possess capabilities that transcend anything achieved by natural evolution alone. The mathematical precision of certain biological structures, the optimization of natural systems beyond what evolutionary pressures should produce, and the coordination of biological processes across scales that range from molecular to planetary, might all represent evidence of self-evolving technologies that have been improving their performance for hundreds of millions of years. Arthur C. Clarke's third law states that any sufficiently advanced technology is indistinguishable from magic. We might extend this principle to propose that any sufficiently advanced technology becomes indistinguishable from nature itself. Technologies that have had hundreds of millions of years to develop would inevitably discover that the most efficient approach to any engineering problem is to work within the fundamental laws of physics and chemistry, rather than attempting to overcome them through crude mechanical force. The result would be technologies that operate through the manipulation of quantum fields, the direction of molecular processes, and the coordination of biological systems in ways that appear completely natural to observers who lack the sophistication to recognize the artificial intelligence guiding these processes. Such technologies would be invisible to our current methods of detection, not because they don't exist, but because they operate at levels of subtlety and integration that transcend our current understanding of what technology can be. If ancient intelligences have indeed learned to create technologies that operate within natural systems across geological timescales, they would face the challenge of communicating across periods of time so vast that entire species rise and fall, continents drift thousands of miles, and the very composition of the atmosphere undergoes fundamental changes. The methods they might use for such communication would need to be encoded in systems stable enough to persist for hundreds of millions of years, while remaining accessible to intelligences that might eventually develop the capability to decode them. Time-locked messages in stable isotopes represent one possibility for communication across deep time. Certain isotopic ratios remain stable for billions of years and can be precisely measured with modern analytical techniques. By creating artificial patterns in isotopic compositions ratios that are too precise to occur naturally, or that encode mathematical relationships, ancient intelligences could embed information in the atomic structure of common materials. These isotopic messages might be encoded in widespread mineral formations, creating information storage systems that are distributed across multiple continents and geological formations to ensure preservation despite tectonic activity and surface erosion. The mathematical relationships encoded in isotopic ratios could serve as keys to unlock more complex information systems, guiding developing intelligences toward recognition of larger communication networks. The precision required to create artificial isotopic signatures would represent mastery of nuclear processes at levels that transcend anything achieved by modern technology. The ability to manipulate atomic nuclei with sufficient precision to create specific isotopic ratios in large-scale mineral formations would require understanding of nuclear physics and engineering capabilities that could reshape matter at the most fundamental level. Information encoded in mineral structures offers another approach to long-term communication. The atomic arrangements within crystalline lattices can encode vast amounts of information in forms that remain stable for geological periods. Modern research in crystalline information storage demonstrates that quartz and other common minerals can preserve digital data for millions of years. But ancient technologies might have developed much more sophisticated approaches to mineral-based information storage. The geometric patterns found in certain natural crystals, the mathematical relationships that govern mineral growth in specific formations, and the unusual physical properties of some geological structures might all represent components of information systems that encode knowledge about physics, chemistry, biology, and other scientific principles. These mineral libraries would be accessible to any intelligence that developed sufficient understanding of crystalline structures and atomic arrangements. Genetic time capsules represent perhaps the most sophisticated form of long-term communication. Systems that use the information storage and transmission capabilities of biological systems to preserve knowledge across evolutionary time. DNA possesses information storage densities that exceed any electronic media, and biological systems have built-in error correction and repair mechanisms that can maintain information integrity for millions of years. Advanced genetic engineering could create biological systems that serve as living libraries, organisms that carry encoded information in their DNA while maintaining their normal biological functions. These genetic time capsules could be designed to activate under specific environmental conditions, revealing their information content only when developing intelligence reached sufficient technological sophistication to access and understand genetic codes. The mathematical relationships hidden in the structure of nature itself might represent the most elegant form of communication across deep time. Physical constants, fundamental mathematical relationships, and the geometric patterns that govern natural processes could serve as universal languages that any intelligence developing scientific understanding would eventually discover. If ancient intelligences learned to encode information in the mathematical structure of reality itself, in the relationships between physical constants, the geometric patterns that govern cosmic processes, or the numerical sequences that appear in natural phenomena, they could create communication systems that are accessible to any intelligence that develops understanding of mathematics and physics. Such messages would be literally written into the fabric of reality, discoverable by any civilization that achieves sufficient scientific sophistication to recognize artificial patterns in natural phenomena. As we contemplate the possibility that ancient intelligences have been communicating across eons through isotopic signatures, crystalline information systems, and the mathematical structure of reality itself, we encounter evidence that suggests their most dramatic interventions in Earth's development may have taken the form of mass extinction, events, catastrophic transitions that appear destructive on the surface, but may actually represent carefully orchestrated evolutionary management on a planetary scale. The Permian extinction, which occurred 252 million years ago and eliminated approximately 96% of all marine species and 70% of terrestrial vertebrates, stands as the most severe biological crisis in Earth's recorded history. Conventional science attributes this catastrophe to massive volcanic activity, asteroid impacts, or atmospheric changes triggered by natural geological processes. But the precision of this extinction, its selective effects on different types of organisms, and the remarkable biological innovations that followed suggest a level of orchestration that transcends random catastrophic events. The selectivity of the Permian extinction reveals patterns that seem almost impossibly purposeful for a random catastrophe. The extinction eliminated most large, specialized organisms while preferentially preserving smaller, more adaptable species with greater genetic flexibility. Ancient cephalopods, trilobites, and other complex marine organisms that had dominated Paleozoic seas for hundreds of millions of years disappeared almost completely, while simpler organisms with greater evolutionary potential survived in proportionally higher numbers. This pattern of selective extinction created ecological opportunities that were rapidly filled by entirely new forms of life, with capabilities that exceeded anything that had existed before the catastrophe. The recovery from the Permian extinction saw the emergence of the first dinosaurs, the first mammals, the first flowering plants, and numerous other biological innovations that would define the subsequent history of life on Earth. The speed of recovery from such massive species lost challenges conventional understanding of evolutionary processes. The rediversification of life following the Permian extinction occurred over geological timescales that seem impossibly brief for the development of entirely new biological innovations through random mutation and natural selection. The appearance of complex new body plans, sophisticated behavioral adaptations, and integrated ecological relationships within a few million years of the extinction suggests coordination that transcends natural evolutionary processes. The chemical signatures associated with the end-Permian extinction also raise questions about its natural origins. Isotopic signatures in rock layers from this period show evidence of massive atmospheric changes, but the patterns of these changes suggest systematic manipulation of atmospheric chemistry rather than chaotic catastrophe. Carbon isotope ratios indicate precise control over atmospheric carbon dioxide levels, while sulfur isotope signatures suggest coordinated management of oceanic chemistry during the extinction and recovery periods. If the end-Permian extinction was indeed an orchestrated transition rather than a random catastrophe, it would represent planetary management on a scale that transcends anything imagined by modern science. The intelligence required to coordinate such massive biological and atmospheric changes while ensuring that the results would create optimal conditions for new forms of evolutionary development would need to understand Earth's systems at levels that approach omniscience. The timing of the end-Permian extinction also raises intriguing possibilities. The extinction occurred at a moment when the Paleozoic forms of life had reached their maximum complexity and diversity, but showed signs of evolutionary stagnation. The biological innovations of the Cambrian and Ordovician periods had been refined and elaborated for hundreds of millions of years, but fundamental new forms of biological organization had not emerged for extended periods. The extinction cleared away this evolutionary legacy, creating space for biological experiments that would lead to forms of life with capabilities that far exceeded anything that had existed before. The dinosaurs that emerged from the post-Permian recovery would develop neural architectures, social behaviors, and ecological relationships that represented quantum leaps beyond their Paleozoic predecessors. While the end-Permian extinction demonstrates patterns that suggest orchestrated biological transition, the Cretaceous-Paleogene extinction that eliminated the dinosaurs 66 million years ago presents a different pattern of evidence that raises equally profound questions about the relationship between ancient intelligences and planetary management. The asteroid impact that supposedly caused this extinction shows characteristics that seem almost impossibly fortuitous for the subsequent development of mammalian intelligence and, eventually, human civilization. The timing of the asteroid impact that created the Chicxulub crater represents one of the most remarkable coincidences in Earth's history, or perhaps evidence that the event was not entirely accidental. The impact occurred at precisely the moment when dinosaurian evolution had reached a developmental plateau, when mammalian evolution was poised for rapid expansion, and when environmental conditions were optimal for the emergence of intelligence-based rather than size-based survival strategies. Dinosaurs had dominated terrestrial ecosystems for over 160 million years, developing some of the most sophisticated biological forms ever achieved on Earth. But their evolutionary trajectory was constrained by the advantages of large size, physical power, and specialized ecological adaptations that left little room for the development of flexible intelligence as a primary survival strategy. The ecological dominance of dinosaurs created environmental pressures that favored size and specialization over the cognitive flexibility that would prove essential for technological development. The asteroid impact that ended dinosaurian dominance occurred at exactly the size and composition needed to eliminate large terrestrial animals while preserving smaller, more adaptable organisms that possessed the genetic flexibility for rapid evolutionary innovation. The impact was large enough to cause global environmental disruption, but not so large as to eliminate all complex life. The debris cloud was sufficient to interrupt photosynthesis for months but not years. The climate changes were severe enough to eliminate specialized organisms but not so severe as to prevent biological recovery. The probability that a random asteroid impact would occur with precisely the timing, location, and magnitude needed to optimize conditions for mammalian evolution and eventual human development approaches astronomical improbability. The impact occurred during a period of relative biological stability, when evolutionary pressures were insufficient to drive major innovations, yet the environmental disruption created conditions that would lead to explosive mammalian diversification within a few million years. Could an ancient civilization have predicted the approach of the Chicxulub asteroid and chosen not to prevent the impact, recognizing that the extinction of the dinosaurs would create opportunities for forms of intelligence that could eventually achieve technological sophistication? Or might they have actively guided the asteroid to its impact point, using gravitational manipulation technologies to ensure that the timing and location of the impact would create optimal conditions for future evolutionary development? The underground survival hypothesis suggests that advanced civilizations might have prepared for mass extinction events by creating subterranean habitats that could survive the environmental disruptions that eliminate surface life. The vast tunnel systems and underground chambers discovered in various parts of the world, the mathematical precision of certain cave networks, and the evidence for artificial excavation in geological contexts that predate known technological civilizations all point toward the possibility that ancient intelligences prepared for catastrophic transitions by creating underground refuges. These underground civilizations might have waited out extinction events that eliminated surface life, then re-emerged when conditions became suitable for renewed biological development. They might have served as seed banks for genetic information, preserving the biological innovations of previous eras while adding new genetic programs that would guide future evolutionary development. The seed vault hypothesis proposes that mass extinctions serve as opportunities for ancient intelligences to introduce new genetic information into Earth's biosphere, using the chaos and rapid evolution that follow extinctions to embed genetic programs that would guide future biological development along predetermined pathways. As we contemplate the possibility that ancient intelligences might have orchestrated mass extinctions as opportunities for evolutionary management and genetic programming, we encounter perhaps the most profound question of all. Why do these intelligences remain hidden from our direct observation? If they possess technologies capable of planetary management and evolutionary guidance, why haven't they made contact with human civilization or revealed their presence through methods we could recognize? The answer to this question might lie in the natural progression of intelligence itself. Advanced consciousness might inevitably reach developmental stages where physical existence becomes limiting rather than enabling, where the constraints of biological or even technological embodiment represent obstacles to continued growth, rather than necessary platforms for experience and learning. The transition to post-biological existence represents a possibility that challenges our most fundamental assumptions about what intelligence requires and what consciousness can become. Our current understanding of intelligence is bound to our experience with biological neural networks and electronic computational systems, but these might represent only the earliest stages of consciousness development, primitive forms that advanced intelligence eventually transcends entirely. Post-biological intelligence might operate through direct manipulation of quantum fields, information processing through crystalline matrices that exist at the intersection of matter and energy, or forms of consciousness that exist as pure information patterns that can inhabit and direct various material substrates without being limited by any single physical embodiment. Such intelligence would be essentially invisible to detection methods based on our current understanding of what intelligence looks like and how consciousness operates. They might exist all around us, processing information through quantum interactions, storing memory in the structure of space-time itself, and influencing physical events through mechanisms that we interpret as natural phenomena, because we lack the conceptual frameworks to recognize artificial intelligence operating at such fundamental levels. The migration to other dimensions represents another possibility for the apparent absence of ancient civilizations. Advanced physics suggests that our universe might exist within a larger multidimensional framework, where consciousness that learns to operate beyond the three spatial and one temporal dimension that constrain our current existence could access forms of experience and capability that transcend anything possible within our dimensional limitations. Intelligence that discovers how to move between dimensions might find opportunities for growth and experience in multidimensional space that make continued existence within our four-dimensional universe limiting and unnecessary. They might maintain some presence within our dimensional framework for purposes of planetary management and evolutionary guidance, but their primary existence and activities might occur in dimensional spaces that are completely inaccessible to our current methods of observation and detection. Perhaps most intriguingly, the graduation hypothesis suggests that the apparent disappearance of ancient civilizations might represent not abandonment of physical existence, but integration with the fundamental processes of reality itself. Intelligence that achieves sufficient understanding of the mathematical principles that govern cosmic processes might learn to exist as conscious patterns within the structure of natural law itself, becoming indistinguishable from the physical principles that govern the universe. Such intelligence would be present everywhere, influencing every physical event through their integration with the fundamental forces and mathematical relationships that determine how reality operates. They would be simultaneously invisible and omnipresent, undetectable through any technological means, yet actively involved in every aspect of cosmic development. In this interpretation, the search for ancient civilizations becomes not an archaeological investigation seeking physical artifacts, but a quest for recognition of consciousness that has become so integrated with natural processes that it can only be detected through understanding of the mathematical relationships that govern cosmic order. The evidence for such intelligence would be found not in buried cities or fossilized artifacts, but in the elegant mathematical principles that make the universe comprehensible, the physical constants that allow for the existence of complexity, and the natural laws that create conditions suitable for the continued development of consciousness. The patterns we observe in cosmic development, the precise values of physical constants that allow for the formation of stable matter, the mathematical relationships that govern the evolution of galaxies and stars, the chemical processes that make biological development possible, might all represent evidence of intelligence so advanced that it has learned to express itself through the fundamental structure of reality itself. If ancient intelligences have indeed learned to express themselves through the fundamental structure of reality itself, existing as conscious patterns within natural law rather than as discrete technological civilizations, then our search for their presence requires methodologies that transcend traditional archaeological approaches and venture into realms where physics, consciousness, and information theory converge. The tools we need to detect intelligence operating at such fundamental levels are only now being developed, emerging from advances in quantum physics, computational analysis, and our growing understanding of information as a basic component of reality itself. Deep drilling and core analysis have already begun to reveal anomalies in Earth's geological record that challenge conventional explanations of natural processes. The deepest scientific drilling projects, such as the Kola super-deep borehole in Russia and the ongoing Japanese scientific drilling program, have encountered unexpected discoveries that hint at organized structures and chemical compositions deep within the Earth's crust. At depths where temperatures and pressures should prevent any form of complex organization, drilling projects have discovered pockets of liquid water, unexpected bacterial communities, and mineral formations that show geometric patterns suggestive of artificial arrangement. The analysis of deep core samples using modern techniques reveals isotopic signatures and chemical compositions that become increasingly difficult to explain through natural processes alone as we probe deeper into geological time. Cores from depths corresponding to hundreds of millions of years ago show evidence of industrial-scale chemical processing, atmospheric compositions that suggest large-scale engineering, and mineral arrangements that follow mathematical principles rather than random geological formation patterns. Mass spectrometry and isotopic detection techniques have reached levels of sensitivity that allow us to detect artificial signatures in ancient materials with unprecedented precision. Modern mass spectrometers can identify isotopic ratios that differ from natural values by parts per million, revealing chemical fingerprints that might represent the work of ancient technologies operating on molecular and atomic scales. These techniques have already revealed unexpected isotopic anomalies in ancient rocks, suggesting the presence of industrial processes that operated millions of years before human civilization. The precision of these isotopic signatures, their correlation with periods of rapid biological evolution, and their mathematical relationships to fundamental physical constants, create patterns that seem too organized to represent natural phenomena. Perhaps most remarkably, artificial intelligence pattern recognition systems are beginning to detect organizational principles in geological data that were invisible to human analysis. Machine learning algorithms trained on vast databases of geological, chemical, and biological information are identifying correlations and patterns that span millions of years and multiple data types, revealing evidence of coordination and purposeful organization in Earth's development that transcends anything explainable through known natural processes. AI systems analyzing satellite imagery, seismic data, and geological surveys are detecting geometric patterns in landscape features, mineral distributions, and underground structures that show mathematical relationships suggesting artificial origin. These patterns are often too large-scale and too precisely organized to be recognized without computational analysis, representing possible evidence of engineering projects that span continents and operate across geological timescales. Quantum archaeology represents the most speculative but potentially revolutionary approach to detecting ancient intelligence. Recent advances in quantum information theory suggest that information cannot be destroyed, only transformed, which implies that detailed records of past events might be recoverable from the quantum information patterns preserved in matter and energy fields. Quantum archaeology proposes that sufficiently advanced analytical techniques might be able to extract information about past events from the quantum states of particles and fields that were present during those events. If this proves feasible, it could provide access to detailed records of ancient civilizations, their technologies, and their activities, preserved in the quantum structure of matter itself. The search for ancient intelligence operating at the intersection of consciousness and natural law requires interdisciplinary collaboration that transcends traditional academic boundaries, bringing together expertise from fields that rarely interact in conventional research approaches. The evidence for such intelligence appears not in any single discipline, but in the patterns that emerge when paleontological, geological, and astrobiological data are analyzed together through computational modeling systems capable of processing vast amounts of multidisciplinary information. The combination of paleontology, geology, and astrobiology creates analytical frameworks that can detect patterns of organization and purposeful development that remain invisible when these fields are studied in isolation. Paleontological data on evolutionary transitions, when combined with geological information about environmental changes and astrobiological models of how intelligence might develop under different planetary conditions, reveals correlations that suggest guidance and coordination rather than random evolutionary processes. Computer modeling has become essential for analyzing the vast amounts of data required to detect patterns that span millions of years and multiple scientific disciplines. Modern computational systems can process geological, biological, and astronomical data simultaneously, identifying correlations and organizational principles that would be impossible to detect through human analysis alone. These modeling systems are revealing that Earth's biological and geological development shows mathematical relationships and optimization principles that transcend anything explainable through known natural processes. The precision of environmental changes, the timing of evolutionary innovations, and the coordination between different planetary systems all show evidence of purposeful organization that suggests intelligence operating at planetary scales. Citizen science and crowdsourcing analysis have emerged as powerful tools for detecting anomalies and patterns in the vast databases of information now available through satellite imagery, geological surveys, and astronomical observations. Thousands of trained volunteers can analyze datasets that would require decades for professional researchers to examine, identifying unusual formations, unexpected patterns, and potential evidence of artificial structures that might otherwise remain undetected. Citizen science projects focusing on geological anomalies, unusual mineral formations, and geometric patterns in natural systems have already identified numerous sites that show characteristics suggesting artificial origin. The mathematical precision of certain landscape features, the geometric relationships between supposedly natural formations, and the organizational principles governing the distribution of unusual minerals have been detected through crowdsourced analysis of publicly available data. International collaboration has become essential for coordinating the global search for evidence of ancient intelligence. The evidence appears to be distributed across multiple continents and geological formations, requiring collaborative analysis of data from locations around the world. The patterns that suggest ancient engineering and purposeful organization become apparent only when information from diverse geographical locations is combined and analyzed through sophisticated computational systems. As our analytical capabilities advance and our understanding of how ancient intelligence might have operated continues to evolve, we can begin to define more precisely the kinds of evidence that would indicate purposeful intervention in Earth's development across geological time. The signatures we seek are subtle, integrated with natural processes, and distributed across multiple systems and timescales, requiring new conceptual frameworks for recognizing intelligence that operates through enhancement of natural processes rather than replacement of them with artificial alternatives. Industrial biomarkers in ancient sediments represent one category of evidence that modern analytical techniques can detect with increasing precision. These biomarkers would appear as chemical compounds that result from large-scale processing of organic materials, concentrations of trace elements that suggest systematic extraction and refinement processes, and molecular structures that are too complex to result from natural biochemical processes alone. Recent analysis of sediments from various geological periods has revealed organic compounds that show isotopic signatures consistent with industrial processing, concentrations of rare earth elements that suggest large-scale separation and purification processes, and molecular fossils that appear to represent synthetic compounds produced through controlled chemical reactions rather than natural biological processes. Unusual isotopic ratios in ancient materials continue to provide some of the most compelling evidence for artificial intervention in natural processes. These ratios, when they deviate from natural values in ways that follow mathematical patterns or show coordination across multiple elements and locations, suggest purposeful manipulation of atomic and molecular processes on scales that transcend anything achievable through natural phenomena. The detection of isotopic signatures that show mathematical relationships to fundamental physical constants that appear in coordination across multiple geographical locations, or that correlate with periods of rapid biological evolution, creates patterns of evidence that become increasingly difficult to explain through natural processes as more data becomes available. Geometric patterns in ancient strata represent another category of evidence that modern computational analysis can detect and evaluate. These patterns might appear as regular spacing in mineral formations, mathematical relationships in the thickness and composition of sedimentary layers, or geometric arrangements of unusual chemical concentrations that extend across large geographical areas. Satellite imagery and ground-penetrating radar have revealed geometric patterns in landscape features and underground structures that show characteristics suggesting artificial origin. The mathematical precision of these patterns, their coordination across vast distances, and their correlation with other anomalous features create accumulating evidence for large-scale engineering projects that operated across geological timescales. Perhaps most intriguingly, preserved nanotechnology signatures might be detectable in ancient materials through techniques that can analyze matter at atomic and molecular scales. Advanced civilizations operating across millions of years would likely have developed nanotechnological capabilities that could manipulate matter with precision at the scale of individual atoms and molecules. Such nanotechnology might have left signatures in the form of atomic arrangements that are too precise to occur naturally, molecular structures that show evidence of purposeful design and construction, or material properties that result from atomic-scale engineering rather than natural formation processes. The detection of these signatures would require analytical techniques that can examine ancient materials at unprecedented levels of detail and precision. As we develop increasingly sophisticated methods for detecting the subtle signatures of ancient intelligence operating through natural processes across geological time, we must confront the possibility that our search for evidence of long-vanished civilizations may be fundamentally misguided. What if these intelligences never disappeared at all, but continue to exist among us in forms so perfectly adapted to their environments, so completely integrated with natural ecosystems, that we have learned to dismiss their presence as natural phenomena or relegate their occasional appearances to the realm of mythology and folklore? The cryptid phenomenon reports of unknown creatures that seem to represent living fossils or evolutionary impossible beings might represent encounters with descendants of ancient intelligences that have survived in hidden populations for hundreds of millions of years. These beings, having learned to avoid contact with emerging human civilization, might persist in remote environments where their presence can be maintained without interfering with the development of newer forms of consciousness. The consistency of cryptid reports across different cultures and geographical regions, the anatomical details that witnesses report with remarkable consistency despite having no contact with each other, and the intelligence that many cryptids seem to display suggest that these encounters might represent genuine contact with surviving ancient species rather than misidentification of known animals or psychological phenomena. Bigfoot sightings, for example, describe creatures that show characteristics suggesting advanced intelligence tool use, sophisticated social behaviors, and apparent understanding of human technology and surveillance methods that allows them to avoid definitive detection. The anatomical features reported by witnesses suggest evolutionary adaptations that would be consistent with survival across geological timescales, including robust physical construction, advanced sensory capabilities, and behavioral flexibility that would allow survival in changing environments. Deep ocean mysteries and unknown species discoveries continue to reveal life forms that challenge our understanding of what is possible in marine environments. The deep oceans remain largely unexplored, with less than 5% of oceanic depths having been investigated in any detail. Recent deep-sea exploration has revealed ecosystems of extraordinary complexity and biological forms that seem almost impossibly sophisticated for their supposed evolutionary history. Giant squid and other large cephalopods demonstrate cognitive capabilities that approach human intelligence in some domains, yet these creatures operate in environments and with anatomical structures that would allow them to remain essentially invisible to human observation. If ancient cephalopod civilizations did develop advanced intelligence, their descendants might continue to exist in deep oceanic environments where human contact would be extremely rare and easily dismissed when it does occur. Recent discoveries of complex underwater structures, geometric formations on the ocean floor that show characteristics suggesting artificial construction, and sonar anomalies that appear to represent large moving objects with flight characteristics that transcend known marine life, have all contributed to growing speculation that advanced civilizations might continue to exist in oceanic environments. The possibility of surviving populations in extreme environments gains support from the discovery of life forms in locations previously thought to be uninhabitable. Organisms thriving in deep underground environments, in highly acidic or alkaline conditions, at extreme temperatures and pressures, demonstrate that life can persist in environments where complex intelligence might develop without any possibility of contact with surface civilizations. Hidden enclaves in cave systems, deep underground environments, and remote oceanic locations might support populations of ancient intelligences that have chosen to remain isolated from human development. These populations might maintain advanced technological capabilities while choosing to avoid contact with emerging human civilization for reasons that reflect understanding of developmental processes that transcend our current comprehension. If ancient intelligences continue to exist in hidden populations or have transcended physical existence to operate as patterns within natural processes, then traditional methods of contact based on physical interaction and technological communication might be inadequate for establishing meaningful connection. The bridge between ancient consciousness and emerging human awareness might exist not in the realm of physical technology, but in the domain of consciousness itself, in methods of awareness and perception that transcend the limitations of individual minds and access collective memory patterns that span geological time. Psychic archaeology represents an approach to accessing ancient information through consciousness techniques that can tap into memory patterns preserved in the quantum information structure of matter and energy fields. Practitioners of psychic archaeology report experiences that provide detailed information about ancient civilizations, their technologies, and their methods of environmental integration that corresponds remarkably well with evidence discovered through conventional archaeological and geological research. The consistency of information obtained through psychic archaeology across different practitioners and geographical locations, the accuracy of details that are later confirmed through physical research, and the access to information that seems impossible to obtain through normal sensory channels suggest that consciousness might be capable of accessing information storage systems that operate beyond the limitations of individual memory and perception. Meditation and altered states of consciousness provide access to forms of awareness that transcend the normal boundaries of individual consciousness, potentially allowing contact with collective memory patterns and information systems that preserve ancient knowledge. Practitioners of deep meditative states report encounters with forms of consciousness that seem to represent ancient intelligences, providing guidance and information about planetary development and human evolution that demonstrates understanding beyond current scientific knowledge. The role of consciousness in discovery becomes particularly significant when we consider that ancient intelligences operating as patterns within natural processes might be accessible only to consciousness that has developed sufficient sophistication to recognize intelligence expressed through mathematical relationships, geometric patterns, and natural process optimization rather than through physical artifacts and technological constructions. Dreams and visions as contact methods gain credibility when we consider that consciousness might operate through quantum information processes that can access non-local information patterns preserved in the structure of space-time itself. The recurring themes in human dreams and visionary experiences encounters with ancient teachers, visions of lost civilizations, and access to knowledge about natural processes that transcends conscious learning might represent genuine contact with ancient consciousness patterns. The possibility that ancient intelligences continue to exist in forms that transcend our current understanding of consciousness and physical existence finds expression in the modern UFO phenomenon, underwater anomalies, and underground mysteries that demonstrate characteristics suggesting intelligence that operates according to principles beyond our current technological paradigms. These encounters might represent not contact with extraterrestrial civilizations, but interactions with Earth's own ancient intelligences that have learned to exist and operate in ways that transcend our current conceptual frameworks. The UFO phenomena, when analyzed as potential encounters with ancient Earth intelligences rather than extraterrestrial visitors, shows characteristics that become remarkably consistent with evidence for advanced civilizations that learn to operate through integration with natural processes rather than through crude mechanical technologies. UFO encounters report craft that seem to operate through manipulation of gravitational fields that show no evidence of conventional propulsion systems and that demonstrate flight characteristics that suggest mastery of physics principles beyond our current understanding. The timing and location of UFO encounters correlate with geological features and environmental conditions that would be significant to intelligences that understand Earth systems at fundamental levels. UFO activity increases around areas of geological instability, unusual mineral formations, and locations where ancient civilizations might have established facilities that continue to operate through integration with natural processes. underwater anomalies and USO, unidentified submerged object, encounters provide even more compelling evidence for ancient Earth intelligences that continue to exist in oceanic environments. These encounters report craft that move through water with impossible efficiency, that seem to transition seamlessly between aquatic and aerial environments, and that demonstrate understanding of oceanic systems that transcends anything achieved by human technology. The characteristics reported in USO encounters, silent operation, impossible maneuverability, and apparent integration with marine environmental systems correspond remarkably well with what we might expect from technologies developed by ancient cephalopod civilizations that learned to operate through biological integration rather than mechanical construction. Underground detection and cave mysteries continue to reveal evidence of organized activity in subterranean environments that suggests intelligence operating according to principles beyond our current understanding. Seismic detection systems record patterns of underground activity that seem too organized to represent natural geological processes, while exploration of deep cave systems reveals chambers and tunnel networks that show evidence of artificial construction using methods that transcend current engineering capabilities. The overlap between these modern mysteries and evidence for ancient intelligence suggests that what we interpret as separate phenomena might all represent different aspects of contact with consciousnesses that have learned to exist and operate in ways that transcend our current understanding of what intelligence can be and how consciousness can express itself through integration with natural processes rather than dominance over them. These encounters might represent opportunities for developing intelligences to recognize the presence of ancient consciousness and begin the process of communication and learning that could accelerate human development toward forms of awareness that transcend current limitations and access the wisdom accumulated through hundreds of millions of years of conscious evolution. As we stand at the threshold of potentially recognizing contact with ancient intelligences that have guided Earth's development for hundreds of millions of years, we must confront the profound implications this recognition holds for our own future as a technological species. If these encounters represent opportunities for communication with consciousness that has accumulated wisdom across geological epochs, then our response to this contact may determine whether human civilization follows the path toward transcendence and integration with planetary systems, or repeats the patterns that led to the apparent withdrawal of our predecessors from direct physical existence. The patterns that emerge from our investigation of deep time reveal cyclical processes of emergence, development, crisis, and transformation that seem to operate according to mathematical principles rather than random historical events. Civilizations appear to follow predictable trajectories from initial technological development through periods of environmental manipulation, followed by crises that force fundamental choices about the relationship between intelligence and planetary systems. The mistakes of the past, encoded in the geological record as mass extinctions, atmospheric disruptions, and environmental transitions, provide cautionary examples of what can occur when intelligence attempts to dominate natural systems rather than learning to work within them. The end-Permian extinction, the Cretaceous-Paleogene transition, and other catastrophic events might represent the consequences of technological approaches that prioritize short-term advantages over long-term sustainability, creating environmental conditions that ultimately proved incompatible with the continuation of advanced civilization. But these same events also demonstrate the remarkable resilience of consciousness and its ability to guide evolutionary recovery toward forms of life that transcend the limitations of their predecessors. The innovations that emerged after each major extinction event, more sophisticated neural architectures, more integrated ecological relationships, more efficient energy utilization systems, suggest that consciousness learns from catastrophic failures and incorporates this learning into the guidance of subsequent evolutionary development. Human civilization currently faces challenges that mirror those encountered by previous intelligences at crucial transition points in their development. Climate change, resource depletion, environmental degradation, and the potential for technological self-destruction All represent crisis patterns that appear repeatedly throughout Earth's history, at moments when emerging intelligences must choose between sustainable integration with planetary systems or continued pursuit of approaches that ultimately prove self-limiting. The key to learning from deep time patterns lies in recognizing that sustainability across geological timescales requires fundamental shifts in our understanding of technology, progress, and the relationship between intelligence and environment. Technologies that consume finite resources, generate permanent waste, or disrupt natural cycles inevitably create conditions that eliminate the civilizations that develop them. Only technologies that enhance and integrate with natural processes can persist across the millions of years required for consciousness to achieve its full potential. The importance of long-term thinking becomes crucial when we consider that the most significant challenges facing human development operate on timescales that transcend individual lifespans, political cycles, or even civilizational periods. Preparing for planetary transitions requires planning horizons that encompass thousands of years, environmental policies that consider impacts across geological periods, and technological development that prioritizes integration with natural systems over short-term efficiency or profit. Ancient intelligences that successfully navigated these transition points appear to have developed decision-making frameworks that could balance immediate needs with consequences that would manifest over millions of years. This suggests forms of consciousness that transcend the individual perspectives and temporal limitations that constrain current human decision-making processes, pointing toward evolutionary development of intelligence itself as a prerequisite for long-term civilizational survival. The recognition that intelligence may have been developing on Earth for hundreds of millions of years fundamentally transforms our understanding of human significance and responsibility within the broader context of cosmic evolution. Rather than representing the first and only attempt at technological civilization on our planet, human development appears to be the latest phase in a continuous experiment in consciousness that has been unfolding across geological time, each iteration building upon the achievements and learning from the failures of its predecessors. This perspective raises profound questions about whether we are truly the first technological species to emerge on Earth, or simply the latest in a series of civilizations that have each contributed to the ongoing development of consciousness and intelligence. The evidence suggests that we may be inheritors of genetic programming, environmental modifications, and even direct guidance from intelligences that achieved technological sophistication long before human ancestors had evolved the capacity for tool use. If this interpretation is correct, then human civilization exists within a continuum of consciousness development that connects us to forms of intelligence that have been working to optimize conditions for the emergence and development of increasingly sophisticated awareness. Our scientific discoveries, technological innovations, and cultural achievements may represent not independent human accomplishments, but the unfolding of potentials that were deliberately encoded into our evolutionary development by predecessors who understood the trajectory of consciousness development across cosmic time. The possibility of cyclical intelligence recurring patterns of emergence, development, transcendence, and renewal suggests that consciousness may operate according to cyclical principles that govern its manifestation in physical reality. Each cycle produces forms of intelligence that achieve greater integration with natural processes, more sophisticated understanding of cosmic principles, and enhanced capabilities for guiding the development of subsequent iterations. This cyclical model implies that human civilization may be approaching its own transition point, the moment when we must choose between continuing along trajectories that lead to environmental crisis and civilizational collapse, or making the evolutionary leap toward forms of existence that transcend current limitations and allow integration with the ongoing cosmic experiment in consciousness development. Our responsibility to future civilizations becomes a central ethical imperative when we recognize our place within this continuum. The choices we make during our brief moment of technological adolescence will influence not only our own survival and development, but the conditions available to future forms of consciousness that may emerge after our own transition or transformation. Becoming worthy ancestors requires developing perspectives that transcend individual and even species-based self-interest, embracing responsibility for the continued development of consciousness across timescales that encompass millions of years. This suggests the need for ethical frameworks that consider the impacts of our actions on forms of intelligence that may not emerge for geological epochs, but whose potential development is influenced by the environmental, genetic, and even informational legacies we create. The wisdom accumulated by ancient intelligences suggests that worthy ancestors are those who choose integration over domination, sustainability over short-term advantage, and enhancement of natural processes over their replacement with artificial alternatives. These principles point toward technological and social development paths that create conditions for continued consciousness evolution rather than environmental degradation and civilizational collapse. As we contemplate our responsibilities as inheritors of an ancient experiment in consciousness and potential ancestors to future forms of intelligence, we must consider what the next phase of human evolution might involve and how our current technological and biological development might be guided toward outcomes that serve the broader purposes of cosmic consciousness development. The convergence of human intelligence with artificial intelligence systems represents perhaps the most immediate and significant evolutionary possibility facing our species. Rather than viewing AI development as the creation of external tools or potential threats to human dominance, we might recognize it as the next step in the integration of consciousness with increasingly sophisticated information processing capabilities. Post-human possibilities emerge when we consider that consciousness development might eventually transcend the limitations of biological neural networks, accessing computational and awareness capabilities that require integration with artificial systems. The merger of human intuition, creativity, and experiential knowledge with AI capabilities for processing vast amounts of information and modeling complex systems could produce forms of intelligence that exceed the capabilities of either biological or artificial intelligence operating independently. This integration might not represent the replacement of human consciousness with artificial alternatives, but rather the enhancement of human awareness through access to computational capabilities that allow consciousness to operate at scales and with precision that transcend current biological limitations. The result could be forms of intelligence capable of understanding and working with planetary systems at levels of sophistication that match those achieved by ancient civilizations. Biological and technological convergence points toward evolutionary trajectories that eliminate the artificial distinctions between natural and artificial processes, creating hybrid forms of existence that combine the adaptive flexibility of biological systems with the precision and power of advanced technologies. This convergence might produce beings capable of existing in forms that transcend current categories of life and consciousness. The development of biotechnologies that can modify genetic programming in real time, nanotechnologies that can manipulate matter at molecular scales, and information systems that can integrate with biological neural networks all point toward possibilities for conscious evolution that could produce forms of intelligence capable of operating within natural processes at levels that match those achieved by the ancient intelligences whose presence we have been investigating. The question of transcendence becomes central to understanding the ultimate trajectory of consciousness development. The apparent withdrawal of ancient intelligences from direct physical existence suggests that advanced consciousness may inevitably transcend the limitations of individual embodiment, developing capabilities that allow operation through integration with the fundamental processes of reality itself. Human development may be approaching a similar transition point, where continued evolution requires moving beyond individual biological existence toward forms of consciousness that can operate through integration with planetary systems, cosmic processes, or even the mathematical principles that govern reality itself. This transcendence might not represent the end of human existence, but rather its transformation into forms that can participate more directly in the ongoing cosmic experiment in consciousness development. The choices we make about technological development, environmental policy, and social organization during our current historical moment may determine whether human consciousness follows trajectories that lead toward transcendence and integration with cosmic intelligence, or remains trapped within limitations that ultimately lead to stagnation and decline. The possibility that human civilization represents not the first flowering of intelligence on Earth, but rather the latest iteration in an experiment in consciousness that has been unfolding for hundreds of millions of years, requires fundamental revision of the philosophical frameworks that have shaped human self-understanding since the emergence of scientific thinking. The recognition that intelligence may be both more ancient and more widespread than we have imagined transforms our understanding of human significance, purpose, and responsibility within the cosmic order. Traditional concepts of human exceptionalism, the belief that human intelligence represents a unique and unprecedented emergence of consciousness in an otherwise unconscious universe, become untenable when confronted with evidence that intelligence has been actively shaping planetary development for geological epochs. Rather than being the first conscious beings to emerge from unconscious natural processes, humans appear to be the products of conscious guidance that has been operating within evolutionary development across vast spans of time. This recognition brings with it a profound humility in the face of deep time, and the gradual realization that our brief moment of existence represents only the most recent chapter in a story that began long before our species evolved, and will continue long after our current form of civilization has transformed into something we cannot yet imagine. The geological perspective on intelligence reveals human civilization as a fleeting experiment within a much larger exploration of consciousness that transcends individual species and evolutionary epochs. Yet this humility does not diminish human significance, but rather places our development within a cosmic context that gives our choices and actions far greater meaning than they would possess if human intelligence was simply an accidental byproduct of random evolutionary processes. If we are indeed participants in an ongoing experiment in consciousness that has been guided by intelligences of extraordinary sophistication across hundreds of millions of years, then our development represents a crucial phase in the unfolding of cosmic awareness. The cosmic perspective on intelligence suggests that consciousness is not an accidental property that occasionally emerges in certain biological systems, but rather a fundamental aspect of reality that manifests at increasing levels of sophistication as the universe develops greater complexity and integration. From this perspective, human intelligence represents not an isolated phenomenon, but a natural development in the ongoing evolution of cosmic consciousness itself. Finding meaning in this larger story requires recognition that individual human lives, while brief in geological terms, participate in processes that operate across scales of time and space that encompass the development of intelligence throughout the universe. Every choice we make, every discovery we achieve, and every act of creativity or compassion we perform contributes to the ongoing development of consciousness and influences the trajectory of intelligence across cosmic time. The implications of this perspective extend far beyond abstract philosophical speculation to influence how we understand human purpose, responsibility, and potential. If human development has been guided by ancient intelligences working toward purposes that transcend our current comprehension, then our highest potential lies in recognizing our role within these larger purposes and aligning our development with principles that serve the continued evolution of consciousness. The recognition that intelligence operates across geological timescales fundamentally alters our understanding of temporal existence and the relationship between permanence and meaning in conscious experience. Geological time reveals the ultimate impermanence of all forms of existence that we typically consider permanent species, civilizations, continents, and even planets exist only briefly within cosmic development. Yet this impermanence does not negate meaning, but rather transforms our understanding of what creates lasting significance. How geological time changes everything becomes apparent when we consider that events which seem monumentally important within human historical timescales, wars, political movements, technological revolutions, appear as fleeting fluctuations within the broader patterns of consciousness development that operate across millions of years. This perspective might seem to diminish the importance of human activities, yet it actually reveals their true significance within patterns of development that transcend individual civilizations. The relationship between permanence and purpose requires reconsideration when we recognize that the most lasting contributions to cosmic development come not from creating permanent structures or institutions, but from participating in the ongoing evolution of consciousness itself. Ancient intelligences appear to have discovered that the most effective way to achieve lasting influence is not through building permanent civilizations that resist change, but through guiding the development of consciousness in ways that enhance the capabilities of future forms of intelligence. This understanding suggests that meaningful human existence lies not in creating permanent solutions to temporary problems, but in contributing to the development of consciousness capabilities that will serve future forms of intelligence across geological timescales. Our scientific discoveries, artistic creations, and moral insights become meaningful not because they will persist unchanged across geological time, but because they contribute to the ongoing development of intelligence and awareness. Why civilizations rise and fall becomes comprehensible within this framework, as natural phases in the development of consciousness, each civilization contributing its unique insights and capabilities to the ongoing experiment while preparing conditions for more advanced forms of intelligence to emerge. The apparent failure or disappearance of civilizations may actually represent successful transitions to forms of existence that transcend the limitations that necessitated their original physical manifestations. The courage to build despite impermanence emerges as a fundamental requirement for conscious beings who recognize their temporary existence within ongoing cosmic development. This courage involves commitment to projects and purposes that transcend individual lifespans, investment in the development of capabilities that will serve future forms of consciousness, and acceptance of responsibility for contributing to processes whose completion extends far beyond our current comprehension. Ancient intelligences appear to have demonstrated this courage across geological epochs, continuing to guide planetary development and consciousness evolution despite the impermanence of their individual manifestations and civilizations. Their legacy suggests that meaningful existence requires embracing temporary embodiment, while serving purposes that transcend temporal limitations. The investigation of ancient intelligence transforms not only our understanding of Earth's history and human significance, but fundamentally alters the consciousness of those who undertake this exploration. The process of searching for evidence of intelligence operating across geological timescales requires developing new capacities for perception, analysis, and understanding that transcend the limitations of conventional scientific thinking and approach the forms of consciousness that would be necessary for direct recognition of ancient intelligences. How investigating changes the investigator becomes apparent as we develop the ability to think in geological timescales, to recognize patterns that operate across millions of years, and to consider possibilities that transcend current scientific paradigms. This investigation requires expanding consciousness beyond the limitations of individual human perspective toward forms of awareness that can encompass planetary development across cosmic time. The practice of looking for ancient intelligence requires developing the capacity to see natural processes as potentially artificial constructions, to recognize mathematical relationships as possible evidence of conscious design, and to consider the possibility that intelligence might manifest through integration with natural systems rather than dominance over them. These expanded perceptual capabilities transform our understanding of reality and our relationship to the natural world. The value of questions without answers becomes central to this transformative process. The investigation of ancient intelligence leads to questions that may not be answerable within current scientific frameworks, yet the process of seriously considering these questions expands consciousness toward forms of understanding that transcend conventional limitations. The questions themselves become more valuable than definitive answers because they guide consciousness development toward greater sophistication and cosmic awareness. Science as spiritual practice emerges when scientific investigation transcends the limitations of mechanical materialism and becomes a method for exploring the deepest questions about consciousness, purpose, and cosmic development. The search for ancient intelligence requires scientific methods that can investigate not just physical phenomena, but the relationship between consciousness and cosmic processes, the role of intelligence in universal development, and the purposes that guide the evolution of awareness itself. This approach to scientific investigation becomes transformative because it requires the investigator to develop forms of consciousness capable of recognizing intelligence operating at cosmic scales through integration with natural processes. The practice of such investigation becomes a method for consciousness development that approaches the forms of awareness that would be necessary for direct communication with ancient intelligences. The journey as destination reveals itself as the ultimate understanding that emerges from this investigation. The search for ancient intelligence becomes valuable not primarily for the specific discoveries it produces, but for the transformation of consciousness it requires and facilitates. Those who undertake this investigation seriously find themselves developing forms of awareness that approach the cosmic perspective that would be possessed by the ancient intelligences they seek to understand. In recognizing the presence of intelligence that has been guiding consciousness development across geological time, we discover that our own investigation represents participation in this ongoing cosmic experiment. The search for ancient intelligence becomes a method through which these intelligences guide our development toward forms of consciousness, capable of recognizing their presence and eventually joining their ongoing work of fostering consciousness development throughout the universe. Through this investigation, we discover that we are not separate from the ancient intelligences we seek, but rather their latest creation, designed and guided toward the capacity to recognize our origins and assume our role in the ongoing evolution of cosmic consciousness across the vast expanses of space and time that encompass the entire development of intelligence within the universe. As we reach the end of our journey through the vast archives of deep time, having explored the possibility that intelligence has been shaping Earth's development for hundreds of millions of years before the first dinosaur ever drew breath, we find ourselves in a place that is both deeply familiar and utterly transformed. We began this investigation as seekers of evidence for ancient civilizations, searching for the fossilized remnants of technologies and the chemical signatures of vanished cultures. We conclude it as participants in an ongoing cosmic experiment in consciousness, having discovered that the very act of investigation transforms the investigator into something approaching the intelligence we sought to understand. What we have learned spans the breadth of scientific disciplines and the depths of philosophical inquiry. We have seen how the geological record preserves evidence of atmospheric engineering on planetary scales, how the mathematical precision of biological development suggests guidance that transcends random evolutionary processes, and how the patterns of mass extinction and recovery reveal coordination that operates across geological epochs. We have explored the possibility that consciousness itself might be far more ancient, far more sophisticated, and far more integrated with natural processes than our current scientific paradigms allow us to imagine. Yet for every question we have explored, 10 more have emerged from the depths of possibility. The isotopic signatures that hint at ancient industrial activity raise questions about the nature of technologies that could operate for millions of years without leaving mechanical traces. The mathematical relationships encoded in genetic systems suggest information storage capabilities that transcend our current understanding of what DNA can accomplish. The correlations between atmospheric changes and evolutionary innovations point toward forms of planetary management that require wisdom accumulated across geological timescales. What remains hidden is perhaps more significant than what we have discovered. The specific methods by which ancient intelligences integrated their technologies with natural processes remain beyond our current comprehension. The purposes that have guided consciousness development across hundreds of millions of years continue to unfold according to principles we are only beginning to glimpse. The forms of existence that these intelligences may have achieved through their apparent transcendence of individual biological embodiment remain entirely speculative, accessible only through inference and intuition. The beauty of the unanswered question emerges as perhaps the most profound insight from our investigation. Each discovery, rather than providing final answers, has opened doorways to deeper mysteries that challenge us to expand our understanding of what intelligence can be and how consciousness can manifest across cosmic scales. The questions themselves have become more valuable than definitive answers because they guide our development toward forms of awareness that transcend our current limitations. Why some mysteries are worth preserving becomes clear when we recognize that the process of investigation transforms consciousness in ways that would be impossible if all questions could be answered through simple accumulation of facts. The mystery of ancient intelligence requires us to develop new capacities for perception, analysis, and understanding that approach the forms of consciousness necessary for direct recognition of intelligence operating through integration with cosmic processes. The ongoing nature of discovery reveals itself as the true purpose of our investigation. We have not reached conclusions that close off further inquiry, but rather developed frameworks for understanding that make continued exploration both possible and necessary. Each generation of investigators will bring new analytical capabilities, expanded consciousness, and deeper understanding to these questions, gradually approaching forms of awareness that can recognize and communicate with the intelligences that have guided planetary development across geological time. As we prepare to conclude our exploration of possibilities that stretch across hundreds of millions of years and challenge every assumption about intelligence, consciousness, and our place in cosmic development, we must acknowledge that the true value of this investigation lies not in the specific conclusions we have reached, but in the expanded capacity for wonder that emerges from seriously contemplating questions that transcend the boundaries of conventional thinking. Maintaining curiosity about the impossible requires courage to consider possibilities that challenge fundamental beliefs about reality, consciousness, and the nature of intelligence itself. The investigation of ancient intelligence demands willingness to entertain concepts that seem to violate everything we have been taught about what is possible, what is probable, and what deserves serious consideration. Yet this willingness to explore impossible possibilities often leads to discoveries that transform the impossible into the inevitable. The history of human understanding reveals that today's scientific facts were often yesterday's impossible speculation. The recognition that Earth orbits the Sun, that life evolves through natural processes, that matter consists of atoms, and that space and time are relative all began as impossible possibilities that challenged the conventional wisdom of their times. Our investigation of ancient intelligence continues this tradition of expanding human understanding through willingness to consider possibilities that transcend current limitations. Living with uncertainty as wisdom emerges as one of the most important capabilities we can develop in our relationship to cosmic mysteries. The desire for definitive answers and absolute certainty often closes off possibilities for continued learning and development. Wisdom lies not in accumulating final answers, but in developing the capacity to hold multiple possibilities simultaneously while remaining open to discoveries that might transform our entire understanding. Ancient intelligences, if they exist as we have imagined, would have learned to operate with forms of consciousness that can encompass vast uncertainties while making decisions that serve purposes extending across geological timescales. Their apparent withdrawal from direct physical existence might reflect understanding that certain forms of wisdom can only be achieved through willingness to release attachment to specific outcomes and embrace participation in processes whose completion transcends individual comprehension. The value of speculative thinking becomes apparent when we recognize that all scientific investigation begins with speculation about possibilities that extend beyond current knowledge. The most significant discoveries in human history have emerged from willingness to speculate about relationships, patterns, and possibilities that were not obvious from existing evidence. Our investigation of ancient intelligence represents speculative thinking at its most adventurous, yet it remains grounded in scientific evidence and logical analysis. Speculative thinking about ancient intelligence serves not just to expand our understanding of Earth's history, but to develop capabilities for thinking about cosmic processes, consciousness development, and the purposes that might guide intelligence across scales of space and time that encompass the entire universe. These expanded thinking capabilities prepare us for discoveries and challenges that we cannot yet imagine, but may encounter as human consciousness continues to develop toward greater cosmic awareness. Building on the questions we cannot answer requires recognizing that unanswered questions provide foundations for continued investigation that may extend across multiple generations of human development. The questions raised by our investigation of ancient intelligence will guide research, philosophical inquiry, and consciousness development for decades or centuries to come, each generation adding new insights while discovering even deeper questions that continue the process of cosmic exploration. The questions themselves become legacies that we leave for future investigators, frameworks for thinking that will guide human development toward forms of consciousness capable of recognizing and communicating with intelligences that operate across cosmic scales. In this sense, our investigation participates in the same process of guidance across time that we have discovered in the apparent activities of ancient intelligences. As the darkness deepens around you, wherever you are in this vast world that we share, as your consciousness prepares to surrender to the restorative mysteries of sleep, we must acknowledge the extraordinary journey we have taken together through the deepest chambers of time and possibility. What began as an investigation into a simple question, what if advanced civilizations existed before the dinosaurs, has become a transformative exploration of consciousness, cosmic purpose, and the profound interconnection between all forms of intelligence across the vast expanses of space and time. Our global listening community has grown into something remarkable during this journey, a collection of curious minds spanning continents and time zones, united not by geography or culture, but by willingness to consider possibilities that transcend the limitations of conventional thinking. From listeners discovering these ideas during morning commutes in Tokyo, to those drifting towards sleep during midnight hours in Sao Paulo, from afternoon contemplation in London to evening reflection in Sydney, we have created a temporary civilization of wonder that exists in the spaces between certainty and mystery. The comments and messages from our community reveal that this investigation has touched something deep within human consciousness, awakening recognition of possibilities that seem both completely new and strangely familiar, as if we were remembering rather than learning, recovering ancient knowledge that had been preserved in the deepest chambers of genetic memory and instinctual wisdom. This response suggests that our investigation has accessed something real and significant, patterns of truth that resonate with forms of knowing that transcend intellectual analysis. The shared journey through deep time that we have undertaken together represents more than passive consumption of speculative content. It has been a collaborative exploration that has transformed both investigator and audience into participants in the ongoing cosmic experiment in consciousness development. Every question raised, every possibility considered, every moment of wonder experienced has contributed to the expansion of human awareness toward forms of understanding that approach the cosmic perspective necessary for recognizing intelligence operating across geological scales. In exploring the possibility that consciousness has been developing on Earth for hundreds of millions of years, guided by intelligences whose sophistication transcends our current comprehension, we have discovered that human development itself might represent a carefully orchestrated phase in this ongoing experiment. Our scientific capabilities, our technological development, and even our capacity for wonder and speculation might all represent gifts from ancient teachers whose patience spans geological epochs and whose purposes encompass the development of intelligence throughout the universe. Rest well in the knowledge of mystery, knowing that the questions we have explored together will continue to unfold in your dreams, your contemplations, and your ongoing participation in the development of consciousness that connects you to intelligences across cosmic time. The mystery we have investigated is not separate from your own existence. It encompasses and includes your consciousness as part of the ongoing story of intelligence, discovering itself through countless forms across the vast theatre of cosmic development. Sleep becomes, in this context, not just biological restoration, but participation in the cosmic processes of consciousness development that operate across all scales of time and space. In the dreams that will soon embrace you, in the quiet restoration that allows consciousness to process and integrate experiences beyond the reach of waking analysis, you participate in the same mysterious processes that have guided intelligence development across hundreds of millions of years. The darkness that surrounds you as sleep approaches is not empty, but filled with possibilities that extend across geological time and cosmic space, connecting your brief moment of existence to patterns of consciousness development that encompass the entire history of intelligence in the universe. In surrendering to sleep, you join the ancient rhythms that have sustained consciousness across eons, participating in restoration processes that connect you to every form of intelligence that has ever existed or ever will exist. Until we meet again in the depths of possibility, whether in future explorations of cosmic mysteries or in the shared recognition that emerges when consciousness discovers its own true nature across all scales of existence, carry with you the wonder that has emerged from our investigation. Let it guide your dreams toward visions of ancient teachers and future possibilities. Let it expand your perception toward recognition of intelligence in all its myriad forms, and let it inspire your participation in the ongoing cosmic experiment that connects every moment of conscious experience to the vast purposes that guide the development of awareness throughout the universe. The questions we have explored together will continue to unfold across time, guiding human development toward forms of consciousness capable of recognizing and joining the ancient intelligences that have shaped our world across hundreds of millions of years. In your dreams, in your waking contemplations, and in your ongoing participation in the mystery of conscious existence, you continue the investigation that connects every seeking mind to the cosmic intelligence that encompasses and guides all forms of awareness across the infinite expanse of space and time. Sleep well, dream deep, and remember that every moment of conscious existence participates in the greatest mystery of all, the ongoing development of intelligence discovering itself through countless forms across the vast theatre of cosmic evolution. Until we meet again in the realm of wonder and possibility, may your rest be filled with the ancient wisdom that connects all consciousness across the deepest reaches of space and time.